good Lord, if you keep watching that, you'll get hypnotized, and then I'll have full control over the entire audience. So, anyways, thank you for tuning in to the 133rd Global Star Party with Uncharted Cosmos. This theme came to mind to me because, of course, it seems like every few days we hear about some major discovery about something that we did not know about before in the universe. But there's also that aspect of discovering things for yourself. You know, you're in your backyard, you're learning how to use your equipment, whether you're doing astrophotography or visual work, and you see something and experience something that you've never experienced before, something you've never seen before. And you know, I'm not talking about aliens or anything like that, but I am talking about maybe finding Stevens Quintet for the first time, or even something as simple but utterly profound as seeing Saturn's rings for the first time. These things have big implications for how they change your perspective and where you think you fit in the universe. And so that's the topic, the theme for this 133rd Global Star Party. I am pleased to have a lot of our regular presenters on tonight, but also a returnee, Hap Griffin, is coming back again for his second Global Star Party, which is great. So we'll get started with David Levy for some commentary and some poetry. David?
Well, thank you, Scott. And I have to tell you that you are a fabulous writer. You sent me some original writing yesterday, and I thought it was just beautiful. I kind of wish you'd read it to everybody after I'm done. But anyway, the theme of this star party about how the universe really is different for each one of us. A hidden universe, perhaps, an unseen universe, perhaps, or just a personal universe. And for me, that brings me back into history, way, way back into history. Probably the most important event in Roman history is probably the one that took place on March the 15th, the Ides of March, 44 BC. When Gaius Julius Caesar was assassinated in the Senate in Rome. And it's kind of interesting to see that because I was studying that in high school just before we had a similar event that took place in the United States in 1963 with the assassination of our president, John Fitzgerald Kennedy. And so in a way, history is a way of repeating itself. One of the things that happened back then, we think, was the appearance of a very bright comet. Caesar's adopted child, Augustus, took over as emperor after Caesar was assassinated, and he arranged a series of memorial games. And during the time, they were held during Julius Caesar's birth month of July, 44 BC, and there were observations done at that time of a very bright comet, possibly the brightest comet in historic times. It is called informally Julius Caesar's comet, and in Latin, Sidus Julium, or Star of Caesar, or the Julian Star. It was also known as Caesaris Astrum. That was Star of Caesar. And isn't Latin a beautiful language? I only know one person who still speaks it fluently. That's Randall Rosenfeld, who has been here on the Global Star Party before, but is not tonight. My quotation tonight is a very short one. In 1599, William Shakespeare decided to revive the tradition of the ancient events in Rome with his play Julius Caesar. He talks a lot about the assassination, even as Caesar in Latin saying et tu Brute, as his friend Brutus is also stabbing him. And so many interesting things happen, but he doesn't talk directly about the comet. Maybe Shakespeare knew something that we don't, or maybe he chose other ways, unseen ways, to borrow from the theme of this week, of unseen, unimagined ways of talking about the comet. And so here comes the quote. It was actually right out of Julius Caesar, and it's when his wife Calpurnia is desperately trying to keep him from going to the Senate that day. She says, "When beggars die, there are no comets seen. The heavens themselves blaze forth the death of princes." In those days, comets were harbingers. And most of us today, now that we are sort of scientists, reject the astrological interpretations. But I would want to say that if it weren't for the work of the astrologers, for thousands and thousands of years prior to the invention of the telescope, we wouldn't have a Hubble Space Telescope. We would not have the James Webb Space Telescope. I don't think we'd know anything about the night sky were it not for the work of the astrologers. And so on that note, I hand you back to Scott Roberts. So thank you, Scott.
Thank you. Thank you. Well, I know that some amateur astronomers seem to get somewhat offended when someone asks them about their astrology, and they're just kind of getting their words mixed up a little bit between astronomy and astrology. But you're right. We owe a debt of gratitude to them. You know, they certainly took it quite seriously, and society took them quite seriously at the time, and I guess some still do. And but if it involves looking up at the sky, it can't be all bad, you know. So, all right, I am pleased to welcome back David Eicher. David is getting ready for a trip over to Europe. For some of the Starmus planning, but tonight we have him, and he has picked, out of all the exotic deep sky objects he could pick, IC 1396. And David, how do you arrive? You've got so much to choose from. How do you pick one? Is it? I'm sure you don't just pick it out of a hat.
Well, to be honest, I had nothing to do last year. I found myself running out of things to do entirely.
Oh, really?
Yeah. And so I got out some really detailed star atlases, and I thought, well, why don't I do a project? So I went exhaustively through some very large format, very detailed star atlases, and I made a list of really interesting, weird, strange objects. And it's possible that a lot of them will show up in a special issue of Astronomy magazine soon. That may have something to do with it, but that's beside the point. So I made a list of all the really weird, interesting objects I could find, just going from the north to the south through all these atlases, and thought about these objects, and came up with a list of 424 objects that were really odd, unusual, standout,
cool,
weird, puzzling, strange objects. And so I'm working my way through the list. And if I weren't sure that you were going to be tired of me way before this point, we would have 8 years worth of stuff on the Global Star Party to talk about on this list.
We need more material.
Okay, so yeah. So there's a little bit of a backlog. As you'll tell with IC 1396, it's in northern Cepheus. We have a long way to go with this. I think we're, 16 or 18 objects into 424 so far. So you can tell me, Dave, I've had enough. Okay, one of these times. Okay, but we're working our way southward, and this is really an interesting object. I've been talking about some really obscure things that there isn't always a lot to say about, but they lie sort of at the perimeter of what amateurs can either visually observe or even image in some cases. This one is a weird, strange, complex object, but it's really much more known. In terms of being studied. And so this one is not going to be quite so, uh-oh, what did I do now? Cancel that. This one's not going to be quite so unusual tonight. It's a little bit better studied. And I will show you some enthusiastic ideas about IC 1396 if I can get to it and start a slideshow. And can you see Centaurus A?
Yes.
Okay, forget about that. It has nothing to
Forget
do
about
with anything. But this is a look perhaps toward, what our galaxy will look like once it's merged with the Andromeda galaxy 6 billion years from now, and we're long, long, long gone on planet Earth for 5 billion years or so at the minimum by then. But anyway, let's go on to things that are more salient, and we'll talk about IC 1396, which is a somewhat large and reasonably bright emission nebula in the far northern sky. It contains a lot of complex objects within this region and within the nebula itself. And it's associated with one of the brightest, intrinsically brightest stars we know of in the entire Milky Way, Mu Cephei. It's a red supergiant. There are also some interesting double stars in the field as well, Struve 2816 and 2819. A huge number of complex dark nebulae are involved with IC 1396. The choicest one is Vandenberg 142. It's called the elephant trunk. It's very well known. It's been imaged with Hubble and with all sorts of other professional observatory telescopes as well. Other dark nebulae, B161 and 160 and 162 and others. So of course, what do emission nebulae do? But eventually, are governed by gravity and compressed down into making new open star clusters. And in this case, it's making the cluster Trumpler 37, which is actually a fairly young cluster. It's about 4 million years old. So this is an object that is really noteworthy because it's a really interesting object in the far northern sky. We think of the far northern sky as kind of bankrupt of really interesting, bright, deep sky objects, but this is one of them. It's actually faintly visible to the naked eye, this nebula, from a really dark site. You've seen it from the Texas Star Party and other places like that are pretty nicely dark sites. It's a degree across, so it's large. And of course, it's a stellar nursery, as essentially all emission nebulae are. The bright star Mu Cephei is really a standout. It's a 4th magnitude star. It's a little bit variable, but it's mostly famous because it was known as Herschel's garnet star. It's a really deep reddish star, and it was a favorite object of William Herschel's among stellar objects. It's one of the largest known stars. It's about 1,000 times the diameter of the sun and 100,000 times more luminous than the sun. So, although our sun is a middle mass and middle luminosity star, we're nowhere near the top of the spectrum, if you will, in both of those ways. And also the nebula are approximately 3,000 light years away. Remember, with deep sky objects, when people will often quote, aside from Gaia distances of really close objects, which are pretty well known, when people say that this galaxy is 61.5 million light years away, we don't know distances to distant objects in the universe anywhere near that accurately. So we're still working on that as time rolls on. This is a really rich area of Milky Way in Cepheus as well, and it's a really nice area, which is not atypical of the far northern Milky Way, and it's a really nice area just to look at with binoculars or a wide field telescope as well, even if you're just exploring what's there. There are lots of clusters and rich star fields that are worth attention. So here's the atlas page, as I've been showing from Ron Stoyan's atlas. That's a pretty compact and moderately pretty detailed atlas as well. And you can see there are a lot of deep sky objects in this tiny little piece of Cepheus Milky Way here. There's IC 1396 smack in the middle here, and you can see that the nebulosity actually extends out to the Garnet Star just north of the nebula there, and you can see how many dark nebulae and other objects are involved with this object, and that there are lots of other deep sky objects just a degree or a few degrees away as well. So it's a really good area to explore. Here with north over to the right, more or less, is IC 1396, and you've probably seen it many times because it's a bit of a pet object for Hubble and other instruments, at least parts of it. It's a large object. And the bright star at upper right here is Mu Cephei, is the Garnet Star. So that's one of the largest, most luminous stars that we know of in our on our side of the Milky Way. And you can see the dark nebula that is on the lower central part of this image of the object is the famous one, is the so-called Elephant Trunk Nebula that's from Sidney Vandenberg's list of nebulae that he made many years ago. Tony Hallis, this is not in the professional observatory image. This is Tony Hallis at the upper end of amateur imaging here. And you can see what a spectacular amount of detail we can see in this dark nebula. And Bart Bach, our old friend David, would be proud of this because there's a lot of gravitational collapse going on here down into what will become Bach globules and little infant stars going on here as well. And you can see it's just a really rich, this is a tiny piece of the nebula, and you can see how many interesting and colorful stars are in this area. This is not the Hubble either. I left that one out. It's a very well-known shot, but this is a little bit more detailed, higher resolution shot that was taken with the almost 1 meter wind telescope on Kitt Peak by Travis Rector. And again, you can see just incredible detail in the elephant trunk here, one of the nicer examples of a dark nebula. And you can, with a large backyard telescope, see this from a dark sky site reasonably well visually as well. In this rich star field. So it's an interesting object to go after. That's all I have on IC 1396. And again, we're very late now in our 50th anniversary year of the magazine. We've got, as I mentioned, some surprises coming up at the turn of the calendar year before we get to the big solar eclipse of next April. Michael and I have written this book, as I've mentioned, on Child's Introduction to Space Exploration to get kids excited about the new era of space. And I will be in Slovakia next week, getting ready for next spring's Starmus, where we've produced a film actually about Starmus that we're going to be introducing next week, and we will have lots of things to announce next week about next spring's Starmus, the 7th Starmus Festival, with lots of Nobel Prize laureates speaking and important scientists from other allied fields, biology and chemistry and other areas, astronaut explorers, and of course some rock and roll with Brian May and others there as well. And so we'll have a lot of fun next spring. We were going to be this week in Armenia, and unfortunately we can't all be doing constructive things and getting along because there's another uptick in the struggle now between Azerbaijan and Armenia, and Yerevan is being flooded with refugees now. So we had to cancel this week. Next week, though, I'll be absent, Scott, from you in Slovakia, but I'll be back the week after.
Great, great.
One
So-
thing I would like to add, if I could, David,
Yes.
I am thrilled that you chose IC 1396 today. It is one of my favorite things to look at the night sky.
Is that right? I didn't remember that, David.
Well, we probably haven't discussed it before, David.
Okay.
But
Yeah.
I just love it. And it was introduced to me by my childhood friend, may he now rest in peace, Carl Jorgensen.
Yes.
And he introduced me to the two multiple stars. It turns out that Sigma 2816 is a triple, 2819 is a double. They
Yeah.
are both extremely easy to separate, and I strongly recommend it for you to look at. It's easy to find, and it's one of the nicest things in the entire sky to look at. And thanks for talking about it, David.
Excellent. Well, I'm so happy to hear that, David, and thanks for adding that. And we'll have another reason to go out and look at it now. Excellent. Thank you, David.
Great.
And-
Well,
and
thank
thanks.
you. Thanks, guys.
Thanks, Scott, as always.
You know, I'm a big supporter of Astronomy Magazine, and you know, highly recommend that you get you know, a subscription, get their 50th anniversary special edition. You know, in fact, get all the special editions because they're amazing and they put a ton of work into them. So, and you don't want to miss out. So David Levy asked me to read my poem, or it's not really a poem, but it's just some writing that I did. I'm trying to exercise some writing, and maybe, and I've worked really hard in the last couple of years in trying to express my views and feelings about astronomy. And so I'll give it a whirl here. Okay, and this is titled Uncharted Cosmos, and I'm going to try to write something. I don't know if I can do it every time, but I'll try to write something for each global star party. So it goes like this. Aim a telescope to the night sky and take a road you have never traveled. You'll explore and discover for yourself as mysteries unravel. Stargazing in the vastness, our egos dissolve, where stars, galaxies, black holes, and what we don't understand evolve. The mind reflects upon our cosmic mirror and loosens our grasp to be free to roam, creating fertile ground to lose our fear of the unknown. The entire universe, including all of us, are evolving and changing in natural ways. You can find peace as you wander and ponder for the rest of your days. That's it. Okay.
Wonderful, smashing, Scott. Thank you for reading that. Thanks for
Thank you.
sharing.
Thank you. I'm turning red here. Anyways. So I really appreciate that. And you guys inspire me to do that kind of stuff. So it's really great. And for any of you that are out there watching the audience and you have something to say, something to present, something like that, look, I'm really happy to have you join us and to experience what the Global Star Party is all about, because we want to hear from you too. So thank you, David.
Thank you, Scott. You have a knack for that. And with poetry, you're a half step away from writing songs. Just saying.
You're a musician, so we were talking about that earlier. Not backstage. I expect to hear some songs from you. So, okay.
Excellent. Thanks,
Okay.
Scott.
Thanks so much, David. All right. Okay, so our next speaker is Carol Orge. Now, Carol joins us regularly. He is the president of the Astronomical League. We try to have a presence from the Astronomical League here every time. And Carol, thank you for coming on. And your talk is going to be about solar eclipses, myths, fun facts, and trivia. So here we go.
Yes, and I've got a tough act to follow. I heard all these unknown talents I wasn't aware of before. So well done, Scott and Dave.
Thanks
Yeah,
so
let's
much.
talk about eclipses tonight. And let me share my screen here. Eclipses, myths, fun facts, and trivia. And in some ways, I'm preaching to the choir. We all know that in ancient times, we had some weird things from our point of view that people believed in back there, as far as the astronomical phenomena, various phenomena. For example, the early Chinese, Babylonians, Greeks, and Hindu, they were able to predict eclipses, but they didn't understand what was behind that, what the science was behind it. So instead, they needed to attribute these events to supernatural causes, and that allowed them to somehow be okay with all that. One fact I'll go to the first one. I was going to talk about the second one, but let's go to the first one. It's reassuring that in 600 million years, we will no longer have solar eclipses because of the slowing down of the Earth's rotation and also the tide system on Earth. So we've got plenty of time to observe some more, but just in case, we need to make sure we try to observe the two coming up this year. One thing I found fascinating that I wasn't aware of before was that helium was discovered in 1868 during a total solar eclipse in India. And I thought that was very interesting. They observed the spectrum of the sun during that eclipse, and that's where we found out about that. Some other ancient responses to eclipse myths. Natives of Colombia, for example, shouted to the heavens, promising to mend their ways and walk on the straight and narrow way. The Norse culture, the gods put an evil enchanter on Loki and got revenge by creating wolf-like giants, some of which would swallow the sun, thereby causing an eclipse. For many people, of course, as we were alluded to earlier, there was a lot of fear involved. And if eclipse occurred during some phenomena at a certain time of the year, they would attribute that to the gods being out of favor with them. Often there was a beast of some kind involved, maybe set out to destroy the sun with some kind of fate, or an angry god. There's a whole spectrum involved in that. In India, many believed that the dragon was devouring the moon and sun, and people really had to defend them against that dragon. The Japanese thought in ancient times that the poison was being dropped from the sky, and they had to cover their streams. Alaskan natives believed that the moisture and dew would cause sickness, so they turned their dishes upside down. What a wonderful thing to think about. And even today, what we think are very modern type times, we think we're quite sophisticated, but even back 15 years ago, for example, in 1991, in Baja, California, when there was a solar eclipse, astronomers were surprised by the weeping and wailing of individual hotel staff because they were terrified of darkness beginning.
Wow.
A few years later, in 1995, an example was given in Cambodia. Instead of screaming and banging during the solar eclipse, soldiers shot into the air to scare the mystic dragons away. And actually, the casualties happened from bullets being aimed in the wrong direction. So that sort of backfired, I guess you would say. As recently as in 2010, during a near annular, out of fear, people stayed home. And of course, we've heard the terror stories over the years of people afraid, schools afraid to let their students go out to see the solar eclipse, even though there was proper shielding available. And just recently, we were honored to have a dinosaur join us in 2017 in Casper, Wyoming for our event there in conjunction with Eclipse. We just staged the dinosaur coming along and thought that would be very appropriate. Actually, I cannot lie. I've got to disclose that was the exhibit in front of the Science Museum, but it made for a good backdrop there. I'd like to put in a plug for Alcon 2024, which will be held on July 17th through 20th in Kansas City. We just pinpointed the date, not the date, but the location. It will be held at the Doubletree Hotel in Overland Park, which is a nearby suburb of Kansas City. And we would urge you to put that date on your calendar now. It will be also available online for viewing. And so we hope you will join us either in person or online for that event. And more information will be forthcoming. And there's my credits. And Scott, back to you. And hopefully we'll have some more of those wonderful verses from you in the future. That was good.
Thank you. Thank you. Well, that's great. Carol, tell us a little bit more about how people can join the Astronomical League. There's still lots of people who don't know how to get involved in our community.
Yes, there are a couple of different ways. The major one is to locate a local league astronomy club in your area, and we can give assistance on that on our website at astroleague.org. And that's probably the easiest way. However, there are other options, such as becoming a member at large. And that gives you all the benefits, or many of the benefits, of being a member of a regular club. For example, many of our members join the league for primarily being able to go out, observe objects with manuals we provide or have available, or else have other ways of doing it. However, a member at large has the same right to go out as part of the membership and observe the objects and get awards for all those. And it's a major motivator, because once one gets one award, it's very motivating to say, well, I did the Messier objects group, which has 110 on it. So maybe I could gravitate to the next. Maybe I live in the city, I could do an urban award. So there's all kinds of awards available. We are up to, I think it's 85 right now. There's something for everyone. We have the Sky Puppies for kids to get them started in astronomy, and something that's not too heavy duty. And we just have something for everyone. And so I'd encourage you to really avail yourself of the opportunities. Our website has lots of observing aids, several of which can be downloaded for use in your own club or personally. And we would recommend that you do that, because there's always, it's good to have some help going through the process of observing the night sky. And so I thank you for your time.
Well, thank you so much. Thank you. I asked the audience this question, and I don't know this about you, but I know you love astronomy, and you've practically given your life over to promoting astronomy in this community. I know you do a lot of other things. We have a great profile page on you. But what was the turning point for you? What was the first time you were like utterly awestruck or surprised about the experience of astronomy?
Yeah. Well, ironically, when I grew up as a kid in the Ozarks, I had these wonderful dark skies. At that point, I didn't appreciate them as far as anything related to astronomy. But I love the beautiful dark skies. However, as an adult, one of my first jobs in Kansas City, one of my colleagues says, you really ought to get out and join our club and see what's out there. And I thought, well, I've seen dark skies before. It's nothing to it. But I got hooked, and that was during the Halley days, Halley's Comet. And sure. I had the comet catcher, the whole 9 yards. Of course, I got afflicted with aperture fever and went on up. And I'll have to admit that there's an 11-inch right now that doesn't get nearly enough work, but I need to work on that. But that's my introduction. And it's just it's one of the most relaxing things I can do in my life, is get out under the night skies and really appreciate the vastness of this universe we're all part of. Mm-hmm. And that's what it is for me. It's just really realizing that we're a part of this whole scheme. Not the only part of it, but an important part of it.
Yeah, that's right. That's right. Well, great. Thanks so much.
Sure.
Thanks for sharing that. John Ray, I asked the audience, and John Ray had mentioned that his first he's watching on Facebook. His first enlightening experience was at a very young. It was as a very young child, sitting by himself at the family's yard at sunset. I looked up and saw the moon. I was awestruck, moonstruck, and it caused me to forever turn to astronomy for everything wonderful in my life. I was 7 years old. Yeah, so that's really cool.
Yep.
And then Andrew Corkill reported back. He said he became interested in astronomy at age 13. And the first big surprise was to learn that there was a public observatory less than 3 miles away from his house. It took him 2 years to hear about it.
Isn't that amazing how that goes, though? Often we
Yeah.
find that phenomena. People in our areas don't understand that we have these facilities here at all. It's
Right.
like they've never heard of anything like that.
Well, it seems like it, and up until the time they kind of get turned on to it somehow, so, and a lot of people have these experiences like these guys where it was kind of something they were doing by themselves. But for all of you that do astronomy outreach, sidewalk astronomy, and sharing the experiences in schools and with your friends and stuff like that, you are really changing minds. You're shaping the way that they see the universe and giving them an important new perspective. So it's I always love to hear about these things. So thanks so much, and thanks for sharing your story. Okay, so up next is Cesar Brolo. Cesar normally comes on really late at night.
Yes.
From Argentina. He's 2 hours ahead of us.
Yes.
He's just back from the am I going to pronounce this correctly? Catamarca?
Catamarca. Perfect.
I didn't roll my
Catamarca.
R, but
Yes. It's original people. We call it original people, or Aboriginal people.
Oh, like indigenous.
Name, yes, Catamarca.
Okay.
And all the cities around, like Tinogasta, and many cities in Catamarca and other provinces are like Arkansas, because Arkansas is a something that is a not English or Spanish name, and
Right.
this is the same for Catamarca or Tinogasta, Fiambalá. Many vocables of cities in Catamarca or in a many another province have the original names. And you know that especially in the northeast of Argentina, we have a mix of cultures between Incas and different original people. It's very interesting because they have a very quantity of archaeological treasures, places where they are continuing make archaeological excavations. Is one of the things that is very interesting in Catamarca, because Catamarca is a huge province inside Argentina, starting in, let me show you a map, sorry. It's more interesting that I speak with a map. For the audience, it will be more interesting.
Geography with Cesar.
Okay.
Good night. Can you hear me good, Maxi?
Yes, I can hear you.
This is more far away than where live Maxi. Maxi really is in my area. Chivilcoy is here. Here is Buenos Aires. Let me share. Yes. I'll show you here. Google Maps, share. Can you see the map?
Yes.
Okay. And well, here we are. As Maxi appear talking, Maxi is in
Más abajo.
here. Okay. And we are going to the northeast, sorry. We can,
Northwest.
yes, northwest, sorry. I'm sorry, northwest. And this is here. It's around, I don't know in distance in miles, it's 2,200 kilometers. I think that is maybe 800 miles, I think. If somebody can make the calculation. And here is the city of San Fernando de Catamarca, and we are going to this, let me show you. Here. It's very near to the city of San Fernando, but they change from Bortle, maybe A, in the city of San Fernando del Valle de Catamarca. En el rodeo is around 3, no more. This year we choose a more near place in Catamarca because last year we went to the Cordillera area, really more far away. Maybe it's an area where you can see anything. It's 60. Let me check. Well, it's more by this area, in the, something that we call it La Ruta de los 6 Miles. But this year we are in this area, especially in this area. If we go to a light pollution map, let me show you. It's not the perfect place.
But it's going to be cold.
Sorry, Maxi, I couldn't understand.
It's going, va a ser mucho frío. Abrigate.
No. It's maybe a little in the night, but it's not like last year in the Cordillera. I'll show you. I'll share screen, the pollution map. Okay. Here is San Fernando del Valle, and Rodeo is in this area. We are going to be in this area.
Looks
I think that is
dark.
Yes, here you have Bortle 3, and it's low comparing with the altitude of the last year. We was at 3,400 meters. 700 meters, 3,700 meters last year, the hotel. And now we are at only 1,000, and the place where we have the is a little more, but it's around, it's around 1,500, no more. Border 3, very dry weather. As say Maxi, of course that it's not a warmer night in this time of the year, but in the day you have maybe 25 centigrade degrees. In the night maybe you have 10. But last year we had near to the Cordillera de los Andes, we had 0. We don't need to turn on the refrigeration of our CCDs. Well, I can show you too some pictures of the last year. Where we have here was the different places that we visited in the side of the Cordillera. Probably next year we returning to the same place because
Very dry. Looks very
yes, this is another place. It's not the place where we are going next week, but this place is amazing, not for astrophotography, if not to make visual observations. And in the day, you feel that you are in the top of the world, because these places that we visited are all over 4,000 meters high. All. Anyone is below 4,000 meters. The hotel is at 3,700, but we was totally amazed, astonished by the quality of the sky. Maybe this was Mark one. All pictures that I took are pictures of cell phone, because we went totally completely amazed to only use our eyes under this incredible sky. You know that it's impossible to understand that this is the typical pictures with cell phones of medium gamma, not the more sophisticated. And this is all that we experimented last year, and was a star party with 70 people. This year we are going to be 110 people. That for Argentina is a great number, because it's a big country in extension, but we are only no more than 45 million people. It's for our quantity of people is a great number for star parties, and especially for this our economic situation now. Because for the people, maybe you can see here the large and the small Magellanic clouds, and this is the best way to explain how we feel in our eyes the sky. I think that was more realistic with this, because was really strong, the big and the small Magellanic clouds in the sky, really at the naked eyes. Well, of course, we carry Dobsonians. Maybe you know this model of telescope that we enjoyed, the First Light 130 with the Exos 100, more RC Cassegrains. The people really enjoy it, the view, the naked eye view of the sky. This year, the sky is going to be more similar to Wortel 3, to our star party in Valle Grande. We thinking to make a crazy place like last year, and another year a normal place for the people, because the altitude sickness really was strong in the people that came the last year. Because if you are at near to 4,000 meters over sea level, maybe you feel a little uncomfortable and sick, and you need time to feel better. This is so far away because actually we are going at only 36 kilometers for the city, and last year for the city of Catamarca, last year we needed another day to go to the mountains because it's in the same province. You are going, the shape of the province is that you are going from the center of the country to the west. Well, and I can show you too some pictures that are full of foods.
So there's lots of reasons to go to Argentina if you're an amateur astronomer.
Yeah, I can show you a small video. Let me show you a little video that that they prepare. I try to share. Sorry that it's not with the most high resolution, but they prepare, they would think that the tourism and culture government, the part of the government dedicated to this area of culture and tourism, they are working with us in a smart way, and they are support us because they understood that the astroturismo for this province is very, very important.
Yes.
They prepare this advertising for tourism, but with the idea to show the province like a beautiful place to make astroturismo, to see the sky. And this is very interesting because it's a very changing landscape and province. It's a province that here in Argentina is maybe the lowest known by the people. In Argentina, when you talk with the people, many people say, "Oh no, I never went to Catamarca," and it's such beautiful, it's incredible. Have a so different landscape and biomes and places where you can enjoy not only the sky, if not the landscape in the day, sports, you know. Well, this was something interesting where you have a place that are really interested in work for the growing for something that started the last year. Last year, the governor of Catamarca visited us while the Star Party, because for them it's very important, and they really are make great support. We have people of the government working with us, very concerned with this activity, and they are making a great plan for teach astroturismo to receive people in the province to show the sky. It is very interesting because they have an idea of this new industry that is in everywhere receive people to show the sky, you know, and it's very interesting. Really, it's very interesting. Well, in all my videos, of course, I have food. I think that we are talking about astronomía and gastronomía. Many times I told that gastronomía with the G in Spanish is something related with the foods. It's only a G of difference, and we told that many times that well, here is the second Jornadas Nacionales de Astronomía Catamarca. Well, we are awaiting for the people next week. We, of course, that we are loving for the next year that we return to probably to the Andes again. That people from many parts of the world, from the audience, are invited, because it's a great place and it's such beautiful place, and the people is really warm, you know. Not only the place, if not the people that receive in a warming, you know, things that are so good. And this is really something that we are working in this. Of course, at my return, I'll prepare a presentation of how was the Catamarca Star Party. Thank you very much.
Thank you so much. Thank you. Okay.
It's a pleasure.
Yeah. We are getting some great comments from people still, from the audience, and let's see. Barbara Harris is watching on YouTube. Barbara has given a couple of presentations on our programs, and she is also a big supporter of the Astronomical League. She said the biggest astronomical fact that was such a surprise to me is learning that when we are looking at astronomical objects, that we are actually time traveling. We are looking back into time. I think that strikes a lot of people. Barry Allen reports, he says, public outreach is a very important part of astronomy to me. RC, watching on YouTube, says, thank you, Dr. Levy. That comment of yours got me interested in astronomy. I'm sure that those comets that David had discovered have gotten untold thousands looking up at the sky. Andrew Corkill said, I was surprised the last time in Lincoln, Nebraska, as local physics students were at an observatory far out of town. I asked about Hyde Observatory, and they had never considered it. They said too much light pollution. Well, you know, with all the new technologies and stuff like that that astronomers have available to them today, observatories that are kind of stuck in, you know, too much lit areas have gotten a new lease on life here. So I think that's great. Harold Locke says, I started seeing astrophotography by a cousin and an old radio buddy. Told my stargazer buddy I might get interested in that hobby, and he sent me his old Criterion 4-inch telescope. Joshua Tree Astronomy Arts Theater is watching on Facebook. I'm not sure who's behind that, but they said, I moved to Joshua Tree, California, and the night sky was so brilliant as compared to Anaheim. I can attest that. I've gone to Joshua Tree many times. That I had to see that fuzzy spot in Orion. So I bought a broken Nexstar 11. This is a Celestron Nexstar 11 at a local swap meet. Fixed it, and that was it. Without the go-to functioning, I hand-guided it around when, to my surprise, M57 centered up, and with a gasp, I was hooked. Yeah, okay, I can relate to that. Yeah, so thank you, Cesar, for
It's a
the
pleasure. It's a
presentation.
pleasure.
Yeah,
Uh,
and
and really, well, I hope to return with the material from the third party in 2 weeks ahead. Thank you very much.
thank you very much. Okay, so next up is Hap Griffin. Hap was on the last Global Star Party, and we're very happy to have you back. So he's a fantastic astrophotographer. He's worked a lot with Pranvera Hysini on asteroid work, and I think he's been an inspiration for many people. So, Hap, thanks for coming on, and what do you have for us tonight?
Well, I appreciate being here. I was surprised that you mentioned earlier about the overall theme of learning things for yourself, and that really really matches with what I'm going to talk about tonight. I'm going to touch on amateur radio astronomy, which is something that's fairly new to me, but it's amazing what you can do with homemade equipment and free software. So that's what I'm going to be talking about tonight. Let me share my screen and go to here. And should be able to, let's see, let's get this. There we go. So we're going to be talking about initial steps in radio astronomy. This is a picture of my observatory group. We have 5 observatories on a dark sky site here in South Carolina. And as you can see there, there's the Milky Way. We all are astrophotographers, so the front of the observatories are open, the roofs are open, and when we have the cameras going and running on automation, we sit out on the deck in the back at night and play guitar and drink wine and count satellites and all that sort of thing. So we have a good time. But the Milky Way is always a big show there. And the question is, and something that I've always wondered, and you know, for the last several decades, I guess as long as all of us have been amateur astronomers, we've been told that the Milky Way galaxy is a spiral. And so the question that I had was, how do we get from what we see as a Milky Way to the fact that it's a spiral where we can't see beyond the dust clouds that are really just right in our immediate area, because light just does not penetrate. We can't see the hardly past the core, much less the other side. And so how do we determine the shape? And so this is the kind of thing that I like to do for myself, is to study on how that was found out, how that was discovered, and try to replicate some of the studies for myself and come up with the same conclusions. This is the front part of my observatory near a little town called Bethune, South Carolina. It's only a Bortle 5, but it's about as dark as it gets around here. And Pranvera's been there many times. And behind this room, there's a warm room with a bathroom and a kitchen and sleeping quarters and the control room and everything. So I don't have to be out here when it's very cold. All the telescopes are remote controlled from the other room. But one thing I was interested in too was David's description of IC 1396. That's a favorite object of mine as well, and one that I shot I think 2 or 3 weekends ago, but I don't have it on this laptop. Anyway, my background is in radio engineering, television engineering, and I spent I guess the last 45 years designing and building radio transmitter sites, satellite uplink sites, television transmitter sites all around South Carolina. So my background is well into radio technology, and so partnering that with astronomy was just a natural thing to do. And of course, if you look at a diagram of the electromagnetic spectrum, what we see is that little sliver. What we see with our eyes and telescopes is that little sliver in the middle of where it's marked visible light. There's a whole lot of spectrum on both sides both higher and lower in frequency than what we see. And so we're limiting ourselves if we only use visible light to detect astronomical objects. And we also live at the bottom of an ocean of air. And the air is transparent to some frequencies, and it's opaque to other frequencies. You can see there, let's see if I can move my mouse here. Right here, where the visible light is pretty much opaque, but it becomes, pretty much clear, but it becomes opaque at higher frequencies, X-rays and ultraviolet light, things like that, which have to be studied from above our atmosphere and satellites. Same thing here in infrared range. That's why the Webb Space Telescope is in space, is because you really can't study infrared from on the ground here. But here's a wide open area in this range from a couple of centimeters wavelength up to about 10 meters wavelength, where the atmosphere is totally clear and we can see lots of detail through it. Now, just like in any optical telescope, the limit of the angular resolution is proportional to the wavelength divided by the aperture. And of course, when you're dealing with microns, which is the wavelength of light, you can get a lot of detail out of a small aperture. But when you're dealing with centimeters or even meters in wavelength, you have to have a huge capture area. And that's why radio telescopes in general are very large. Now here's a number of frequencies. This is a list of frequencies that the governments of the world protect for radio astronomy. Each material or molecule on the left over there gives off a certain frequency in a space environment. And the one that I'm particularly interested in is circled there, is blocked out as neutral hydrogen, that gives off a radiation frequency of 1420.406 megahertz. And that can be received on a proper receiver. Now, how that works is that in any one single atom of hydrogen, on average, once every 10 million years, the electron, which is normally spinning parallel to the proton, flips its spin. And that's called a hyperfine energy transition, because that state where the spins are opposite has a slightly lower energy than the normal state where they're the same. And so a photon is emitted, and it turns out that it's been calculated that it has a wavelength of 21 centimeters or a frequency of 1420.405750 megahertz. Now, you would think once every 10 million years wouldn't be very significant, but put 10 million atoms together, and you've got a once every million years, put a gazillion atoms together, and it basically turns into a constant signal. If you think about a hydrogen cloud in the arm of the galaxy that might be light years across, it's basically radiating a constant signal at that wavelength. Now, this was theorized back in the 30s when quantum mechanics was first being researched, and it was finally discovered. The signal was actually discovered in 1951 by two researchers at Harvard University. And this is some of the first maps that they made of the hydrogen in the galaxy, which shows that there is some sort of a circular, maybe a spiral detail to it. And I'm going to follow up on that with some homemade equipment here and show you what can be done. This was my first attempt at it last year, just to see if I could pick up the hydrogen at all. And this is a small, about a 1 meter diameter Wi-Fi antenna. I had to modify the feed so that it picked up that frequency, the 1420 megahertz frequency, better than the Wi-Fi frequency, which is 2500 megahertz. And sure enough, I was able to get it. Now, this is basically a block diagram of the real simple radio telescope that I put together. It's a modified Wi-Fi antenna that is fed into a low noise amplifier that you can actually get on Amazon for about $40. And fed by another, or followed by another amplifier module that's also on Amazon, and followed by a software-defined receiver. It's just a little USB dongle that's about another $40 that you can get on Amazon. So all of this together, I've got maybe $120 in it. And then I use my laptop with some free software called SDR Sharp, and I use Stellarium to figure out where the Milky Way is, so I can see when it's pointing, or when my antenna is pointing towards it. The antennas that I use are fixed, and so I aim them due south and basically let the Earth's rotation rotate the Milky Way through the beam of the antenna.
Mhm.
Now here's what we're up against. Radio astronomy signals are extremely weak. They're named after a guy named Carl Jansky, which did a lot of the original research for Bell Labs. An idea of what a Jansky is would be the signal strength of a cell phone from the surface of the moon. So you can see we're dealing with extremely small numbers here, and our signal strengths, and the strongest Milky Way sources are around 2,000 Janskys, and so I'm easily able to see these. So my little small radio telescope is obviously got a sensitivity of better than 2,000 Janskys. These are some typical amateur radio telescopes that people have used. Some old satellite TV dishes. They made some horn antennas, like over to the right, out of aluminized house insulation. The dimensions for these are all over the internet, and they work really well. This is what I'm using now. This is a 1.8 meter modified microwave antenna that I got from the scrap heap where I work. And I built the frame to hold a homemade feed horn on it. And it's placed at my observatory complex, and it's remotely controlled from my house here about 50 miles away. These are some details of it. You can see in the upper left, the feed horn itself is a 6-inch piece of stovepipe, which turns out to be exactly the right diameter for a 21 centimeter wavelength waveguide. You can see some of the electronics down below that are built into a plastic waterproof box from Lowe's. And then I built a mount for it where I could adjust the elevation and the azimuth angle. I plan on motorizing that eventually, but I'll probably end up with a bigger antenna before that. Just a little bit of idea about, so we can talk about where some of the geometry of the galaxy. The galaxy is in 4 quadrants. Quadrant, you can see where the sun is there, which is about halfway out from the center in one direction. Quadrant 1 is basically what we see in our summer Milky Way. Quadrant 2 and 3 we can see in the northern hemisphere as the winter Milky Way, but we pretty much can't see much of Quadrant 4 from the northern hemisphere. That's where the Magellanic clouds are, off in that direction, and you pretty much have to go below the equator to be able to see that area. Obviously, we see a different scene at night when the Earth is in the summertime position versus the wintertime position. And so that's why we see a different version of the Milky Way. We see towards the center of the Milky Way in the summertime. We see towards the outer part of the Milky Way at night in the wintertime. Now, the Milky Way has coordinates just like the sky does, just like we have latitude and longitude on Earth and right ascension and declination in the sky. There's also latitude and longitude in the looking at the Milky Way. 0 degrees longitude is looking directly towards the core from where we are. Positive latitudes are above the equator of the Milky Way. Negative latitudes are below. And the project that I'm going to talk about here is primarily looking along the plane of the Milky Way, as depicted by that line there. The center of the Milky Way, again, is 0 longitude, and all of my measurements are going to be along that horizon of along that equator of the Milky Way. Here's another picture showing 0 degrees longitude, and as you go out to the left, there's 60 degrees, 120 degrees, and it wraps back around, back over to the other and comes back, and 360 is obviously equal back where you started. Here's a radio picture at 408 megahertz of the galaxy, a panorama, and you can see how the center is really bright. We can see some bright spots in Cygnus and Cassiopeia. We see some extragalactic sources, some loops up above, but we still don't see a spiral. what I'm going to be doing with this project is we'll reveal the spiral. Now, if we were just to be looking at a pure signal from hydrogen on a spectrum analyzer, or the type of receiver that I'm using, where frequency is along the x-axis and amplitude is on the y-axis, we would see a single pure vertical line. But what we actually see is a Gaussian frequency distribution. And what this is caused by is spectrum spreading from Doppler shift. These clouds that we're looking at have random motion within these hydrogen clouds, that where some of the hydrogen is coming towards us and some is going away from us. And so we have Doppler shift, both positive and negative, that causes these emissions to give us these Gaussian frequency distributions. And more likely, what we see is that Gaussian distribution that in itself is offset from the normal standard of 1420.406. If it's shifted to the left or lower in frequency, then that means that the object is moving away from us. In visual terms, that would be called red shifted. If it's shifted to the higher end of the spectrum, then that's called blue shifted, and that means that we're heading either towards it or it towards us. So we can tell the amplitude and the speed along the line of sight by looking at the radio spectrum. And what we generally find is that when we look through the galaxy, we see multiple signals at different Doppler shifts. And so what we're seeing is multiple hydrogen clouds, and those hydrogen clouds are the arms of the galaxy. Now we have, when we're trying to measure speed, there's a lot of local motion that we have to take into consideration. We're in orbit around the sun. We are spinning on our own axis, depending on how far you are above the equator. That depends on, or that determines what your rotation rate is. And so all of that has to be referenced to something called the local standard of rest. And it turns out that radio astronomers have determined that is the center of an area that encompasses the dozen closest stars to us. And so there's a way that you can calculate what our motion is within that standard of rest area, and you subtract that out from the motions that we measure by radio astronomy. And it gets complicated, but thank goodness there are calculators on the web that help a lot with that. And it's sort of like if you were on a roller coaster going all up and down and around and back and forth in an amusement park, and you were asked to find the speed of a train off in the distance. What you would have to do would be to measure or figure out your instantaneous motion and subtract that from the motion of the distant train to get a sort of a realistic relative to a local standard of rest measurement. And that's what we do. Now here is what you see. Down below, I've got stellarium running, and you can see right about now there's the equator passing by of the Milky Way. And if you look at the spectrum in the upper left graph, what you'll see is the frequency right around 1420.405 megahertz. And as the Milky Way comes into the beam of the antenna, which is depicted by that circle at the lower right, you'll see the signals come up, and you'll actually see them move due to Doppler shift and different signals at different levels within the Milky Way. And so that's what I'm doing is, let me try to move through here a little faster. This is what I'm doing. I'm doing a systematic study of the galaxy, starting at the center and moving eastward every 10 degrees, since the beam width of my antenna is about 8 degrees. So I don't really want any overlap. And I'm capturing spectra, the radio frequency spectrum, as that location passes the meridian, because my antenna is aimed due south because it's not in motion right now, or not movable. And so over the last year or so, I've captured all of the points along the equator that we can see from my location during the year. And let's see. So what we end up with is a spectrum that looks like this. This is a typical radio spectrum from 80 degrees galactic longitude. And the vertical line there is the reference. That is the hydrogen frequency as it's not shifted one way or the other. But what we see there is 3 different humps. One of those is right near the hydrogen frequency, and so there's not red shifted or blue shifted very much, and that's just the hydrogen that's around us in the arm that we inhabit. Then there's 2 other arms that we are seeing off to the right, and the numbers down at the bottom is the velocity corrected, calculated from the frequency shift, but also corrected for that local standard of rest. Now, one thing to realize, and I'm almost done here, is that before we get to the meat and potatoes, is that our orbit around the sun can be shown on a graphic of the galaxy here. And just like the Keplerian motions of our own solar system, everything within our orbit or closer to the core is orbiting faster than we are. But everything outside of our orbit is orbiting slower than we are. And you can see that in the frequency shifts of the results. Now, for instance, if I'm aimed at 0 degrees galactic longitude, in other words, the antenna is aimed by that yellow arrow over to the left, aimed directly at the core, everything in its line is traveling relatively the same speed in terms of radial velocity. It's not coming towards us, it's not really going away. And so all of the signal is kind of crammed up around the reference frequency. There isn't very much shift. But as we move to the east, this is at 28 degrees galactic longitude, we see multiple humps develop, and we can see the Doppler shifts. And if you compare them to this graph, which is an actual official NASA, best as we can estimate, map of the galaxy, you can correlate every hump in these radio spectra to the arms of the galaxy. Note that at that in that direction, a good bit of well, there's motion in both directions. Now, the thing that excites me the most is that little hump over on the right. And if you follow the galaxy, follow the arrow, that is the Scutum Centaurus arm on the other side of the galaxy. And so we're seeing clear, 70,000 light years across through the muck around the middle of the galaxy, and we're seeing hydrogen in an arm on the other side of the galaxy. And as we move further east, the spectrum changes. What happens is that we move from seeing most things traveling faster than we are to traveling slower than we are. And so the graphs move over to the right where they're blue shifted, and we're catching up to all of these hydrogen clouds basically. And as we go on around. And so I've done this for the whole number of points that I could see from South Carolina. And if you graph all of this, what happens is the spiral shape of the galaxy falls out of it. It's really amazing. And so by using a little small backyard radio telescope, I've duplicated basically the research that was done in the 50s and 60s that determined that we live in a spiral galaxy. And, it's all done with this homemade equipment here. Some of it's from Lowe's, some of it's from a junk pile, some of it's from Amazon. And what I'm working with now is I'm working with a Facebook friend who's a mathematician, and he's helping me to develop some automated data analysis using Excel to find what the amplitude and Doppler shift is of every component that makes up each of these spectral signals. So basically, out of all of this, we can make several deductions. We're surrounded by hydrogen in distinct areas, so it's not a non-uniform structure around us. These areas all have different relative radial velocities to us. Within each area, the hydrogen is randomly distributed with motion both towards and away from us. That gives us the Gaussian frequency distribution of the humps. And we see different spectral patterns as we look at various points along the equator of the Milky Way. And by plotting these radial velocities at various angles, along with a bit of math, the spiral pattern emerges, which to me just blows me away. Moreover, the relative velocities versus distances from the core, if you extend this, and I've got more material on this that I don't have time for, you actually find that that our galaxy does not follow pure Keplerian mechanics, and that leads to the conclusion that we are immersed in a group of dark matter, that dark matter surrounds the galaxy and gives it more mass that we really can't see. So I've got some future goals there, but I'll go ahead and move on to questions.
Okay, all right. We're going to ask a couple of questions here, Hap, and they have to do with building your own radio telescope. Adrian Nowick from YouTube he wanted to know, his first question was, how did you modify your antenna? Was there any modification or?
Well, I guess he's talking about the first one. The reflector itself is a parabolic, so it's not frequency sensitive, other than the fact that the spacing between the bars has to be less than a half a wavelength at the frequency that you're going to be using for it to be an effective reflector. The feed point is what determines the actual frequency of the antenna's operation. And of course, a Wi-Fi antenna operates at 2.5 gigahertz or 2,500 megahertz, and I needed it to operate at 1,420. So I took apart the little dipole feed in it and reconstructed it with a longer element that matches the lower frequency, and I also backed it up a quarter wavelength behind the driven element with a reflector. And it turns out that a compact disc is the perfect diameter to form a reflector for 21 centimeter radiation. So because it's aluminized, and I just glued it onto a little piece of PVC pipe that was a quarter wavelength long, and that cleans up the pattern of the antenna and keeps radiation coming directly into the radiator that doesn't reflect off of the reflector from coming in out of phase and doing some cancellation. So it helps the pattern and the gain of the antenna.
I think there's a group of people here watching right now that want to build their own radio telescopes. So
yeah, and I would like to do a magazine article at some point on this, because it really is fairly simple. A lot of these antennas, I'm trying to think of the name I was using earlier, but you can make them out of anything that any kind of aluminized plate, like a lot of guys use these styrofoam sheets that you insulate your house with.
right.
That have
It's already
foil on one side.
aluminized.
Yeah,
And
you make a cone or a waveguide of the proper dimensions, and it's just a matter of going to Lowe's and buying $10 worth of insulation, and you got a radio telescope antenna.
Yeah, so those of you watching, when was the last time you only spent $10 on a piece of astronomical gear? Okay,
Really,
so
and
I can
things
see
like
all the way across our Milky Way.
yeah, and the feed horn on mine is a piece of 6-inch stovepipe, which
That's
turns out to
awesome.
be the exact dimension you need for a circular waveguide, and the rest of it is just scraps from your hardware bin, from your junk box, and some pieces that you can pick up on Amazon.
I love it.
And I'm seeing radio waves, like you said, from 70,000 light years away.
What's most important here is that a lot of us will read things that's coming from what we believe to be reliable scientific sources and stuff, but how many of us actually get out there and try to prove it to ourselves? And so that's something that is
that's
really,
the whole point of this.
That's really great. So
I always like to, and I've written some
respect
things
for you for that. That's great.
I love to figure out, how do we know what we know?
That's right. That's right. Wonderful, Hap. Thank you for coming on. I hope to have you back on again, because the audience is really turned on by this. Thank you so much. All right. Okay, so we are going back down from the USA down to Argentina again, to Maxi Falares. And Maxi, thank you for coming on to the 133rd Global Star Party. What do you have for us this week?
Well, good night, everyone. Thank you for inviting me. Sorry if I'm going to cough, because I'm kind of sick right now, but anyway,
That's
Good
I
the
night,
nice
will.
thing
Max.
about being on virtually is that they can't catch whatever you
Yeah.
got.
No, sorry. No,
It's
you,
It's
okay.
not my
you,
contagious.
no. You can think about my wife this weekend because she tells me that I'm going to sleep on the couch
Ah,
because uh, all the night I was no, it was impossible even for me, you know. But
mhm.
you know, I give it an advantage for that, so I've been doing astrophotography. So
Yeah,
anyway,
yeah. We'll
everybody
keep you
wins.
company. We'll keep you company.
Well, good night, everyone. Thank you for inviting me. What I'm going to show you, sorry, is what I've been doing last Wednesday and weekend because I was working in different objects. In this case, again, practicing to Saturn because we are in planetary season, but also try to capture the moon, the surface, and the craters to see what I will get with my Dobsonian telescope. But I put it anyway on my equatorial mount, you know. But let me share my screen. Okay, do you see it?
Yes.
Yes.
Gr- Great. So, uh, well, basically, what I've been doing was, like I said, capturing the moon last Wednesday, and I was working with a Barlow 3X and a dedicated camera for astrophotography of deep sky objects. But anyway, I work with ROI resolution. And for example, this is one of the first results that I get that night. This were from the edge because the moon is going to be a full moon. So I only had nights before that. So I want to see some craters and, practicing planetary capturing, lunar capturing. And for example, this is another one. This cost me a lot of gigabytes. Sorry. A lot of, like I said, a lot of gigabytes of data because this is almost the field of view with the Barlow 3X. Let me put it on 1:1, and it's like you are orbiting the
Mm.
surface of the moon. So,
Hmm.
and of course, this particularly crater that calls Pythagoras, you know, I was blown mind to have this because you can see the shadow of this nucleus of the crater uh, showing almost touching the fringe of the crater. And I think this crater was almost 70 kilometers of diameter, almost. So basically, it's like travel from here to Mercedes, another city from here. So anyway, I really love to practice with this, and the night, for doing this was a really good one because the atmosphere was very stable. So I give it a chance now with more less resolution, sorry, to again, but the same uh, field of view. And now I turn it upside down because I want to see the perspective of this one again, but in the different way. And like I said, it's incredible to see the shadows in the surface of this crater and this nucleus here and the border that has also his shadow. And it's like I say, it's like you're orbiting the moon is incredible, and only with a 8 inches telescope. Then more later, I went to capturing the Saturn. I was doing almost 20 videos of 1.5 minutes every one, and each one, sorry, and then they rotate and stack both of them. So I have these results, and I really love the sharpness that I get for that night. Sorry. And you know, now we are going more farther from Saturn, but anyway, you can still watch it, and sometimes you can see some moons passing by. And of course, if you have more diameter of or aperture, sorry, of your telescope, you're going to see much more details, and even sometimes the shadow in the surface of the planet. So sorry. Then the weekend, I grabbed my equipment outside, and I was preparing. I did a little video to share on the social media, and I don't know if I can put here, Scott, because it is in Spanish. But
Okay.
anyway, I want to show you. But first of all, uh, if you can't hear anything because I want to change the mixer stereo. Let me. Okay, do you hear me?
I hear you.
Uh,
Yes.
Okay, yes, because I'm changing the. Now, do you still hear me?
Yes.
Right. So it's going to be more with the sound. Me, do you hear the sound bar now? No. Okay. Well, anyway, let me put it on.
And we don't hear any audio, so you might want to speak up.
That's.
Yeah.
Let me. Maybe if I share this. Uh, Now did you hear it? No.
No.
So let's put this again. So anyway, if you find me on my Facebook page, you can see it. But like I said, it's going to be in Spanish. Uh, so well, what I was saying on that video was that I was preparing my equipment to take pictures or all night to one single object that was the Helix Nebula that is in Aquarius. Here's the night sky from the southern hemisphere, and you can see here is Saturn and Fomalhaut a star, but between those objects is the Helix Nebula, and this red square. Do you see it or not?
The red square?
You can see it, the sorry, the mirror, the window of the stellarium.
No.
Okay, sorry. Well, now
Now,
Yeah.
yes.
Okay. Sorry. Um, so like I said, well, this is my field of view of this object, and it's between Saturn and Fomalhaut on these days in Aquarius constellation is here, and then I went almost 2 nights of capturing this object above the 40 degrees because this single object is really high up, crossing almost my zenith. If I put this, here's the object, and you can see it's almost at the zenith of my sky. So it's a really good one to capture, and even if you are in a pollution area using like I use L-extreme filter, it will going to help you for that. So let me show you what I get. This is sorry. Okay, this is a single picture of the night. Like I said, this is a square sensor. So this is the field of view that I get with my F4 telescope. And you can see here is the nucleus star and surrounded the ionized, well, gas ionizado. That gives you the lights and the colors of this place. So I doing the processing, the stacking, and what I get was this, which is the DBA image. So it changed a lot between, I really love to see like this sun rays, but between these thin clouds. And this is my first time that I get these results. I did the last year, but with the L-extreme filter helps me to give these details. So what I get for that to compare when I process the image was this, and it changed a lot of the colors and the details. Like you can see, the colors and the shapes of the clouds are really thin, and I really love to try this object again. And I'm really happy, but I'm still working on it to continue processing, and well, what the result that I will get, that I'm going to like the results. And the bonus for this night was that I give a chance because we have the Large Magic Chinese Cloud rising up. So I give a chance to NGC 2070. And the result of that night, only 1.5 hours was this with the same gear. And of course, the structures are completely different. And the small clouds of dust and colors and shapes are incredible. It's like a painting object.
It's beautiful.
So I was working with the 4X palette to try to get these colors and shapes, but I'm still working on it. But this object I will capture in a couple weeks maybe to see what I get. So, well, this is for all for me tonight. thank you for inviting me, and I'm glad to see you all again. And I'm glad to see you again, Jerry, that you came back with us. So, well, Cesar, enjoy your vacations next week, and
Thank you, Maxi.
Thank you.
Yes.
and send us pictures of those really pretty good nights.
Okay, I'm carrying wine for you, babe.
You're carrying the wine.
Come on.
Thank you.
Okay.
A lot of
Okay.
people here to carry the wine.
Take care. Take care.
Yeah. So, yeah, a lot of people wishing you well, Maxime, and that you get better soon. So, but thank you.
Thank you,
I mean,
everyone.
That's really, you know, great.
If you see my desktop right now, I have my nebulizer
nebulizer
steam machine. Yeah. And now it's on my path to open my lungs.
Yes.
So, but
Yeah.
I
I
have
hope
to
you get
keep
better.
recovering. Thank you.
Thank you. Take care.
Yes.
Okay. All right. So coming up next is Jerry Hubble. Jerry has not been on for a while. He's been missed by not only us that give presentations here, but by our audience. And Jerry, thank you so much for coming on to the Global Star Party again. And I see you're still at the Star Party.
There, now I can talk.
Okay, your audio is a little down. We need to pick
Is
up
it?
the volume.
Let me see if I can do that. Set microphone.
While he's doing that, Scott, can you hear me pretty good?
I sure can.
Awesome. I just wanted to double check that.
Yep. And Myron, how are you doing?
I'm doing good. I'm in my
Good.
garage now, so if it's a little echoey, that's why. It's the only peaceful place in my house right now.
Oh, okay.
Can you hear
Excellent.
me good? Maybe I just need to talk louder. Is that better?
It's
still kind of-
still very low volume.
Really? Huh. How about now? Same?
About the same.
Yep.
I'm not sure. Let's see here. Why don't you go ahead and just start talking, Myron, and I'll see if I can work this out.
Okay, I can do that.
All right. I'll let you guys sort this out. But
Yeah,
okay.
if you want to kind of listen in, Jerry, while you're doing that, I might ask you to if you can share your screen for some of the videos.
Yeah,
Would
yeah.
you be awesome? Cool. Okay. Well, hello everybody. It's really fun to be here. I've been away too for a while doing other stuff, and life happens. You know how that is. But I'm Myron Wasuda. I live in Virginia, and I have a partner in crime, Jerry Hubble, who both of us operate a small remote observatory here in Virginia called the Mark Slade Remote Observatory. And Scott and Explorer Scientific have been generous benefactors for that. And we've been, our purpose is to just try to bring telescope time to teachers and students and amateur astronomers from around the world. But lately I've been distracted with another activity, and that involves having access to a really large refracting telescope. I live fortunately only about an hour from Charlottesville, Virginia, and in Charlottesville is the campus of UVA, University of Virginia, and on campus they have a 26-inch Clark refractor. It's the observatory is the Leander McCormick Observatory, and the Charlottesville Astronomy Club meets there every month. And as one of the benefits of membership of this club, you get to look through this telescope. Well, looking through it's a lot of fun, but I'm never happy just looking through a telescope. I want to test it. I want to put it through its paces to see what it can do. And to really do that, I need as much time as I'm able to get on the telescope. And fortunately, I've got a good friend down there in Charlottesville. His name is Boris Starasta, who is the observing director at Charlottesville Club. And he's basically as enthusiastic as I am about observing. And I've pitched several projects to him about this telescope. And one of them was I'd like to start using it to just capture astrophotography, video images of the moon. And sorry about that, my phone just left. And to to maybe make animations that are not possible with smaller instruments. And using the immense focal length of this telescope and the resolution capability, I think that opens up a number of cool projects, one of them being high resolution lunar imaging and planetary imaging using CMOS cameras. I thought, what the heck, this might be a really cool telescope to do that with. So what do you do with a new telescope that you get? One of the first things you do is you star test it, right? You go, okay, how good is this telescope? So the very first thing I did with this 26-inch f/15 refractor was we aimed it at Sirius this past winter and last December. And I was able to, using my iPhone, and I don't have this video, I don't think I sent it to Jerry, but using the iPhone, I was able to do a pseudo focal test with it by keeping Sirius just off the center of the field of view, and then using my iPhone afocally to image the star's pattern through the telescope with the eyepiece out. So I moved the camera lens in place of the eyepiece around just a little bit, almost like you would be using a micrometer. And I got it to the point where the image of Sirius was just on the very edge of the view. And so you see this shimmering, brilliantly lit lens that has the seam pattern kind of flowing across it like ripples in water. And superimposed upon that seam pattern are the potential optical defects in the lens. And it's almost like a Raunchy grading. It's kind of a hybrid between a Raunchy grading test and a focal test. And I was just amazed at how I could see little dust specks on the lens. And I could see just how good this lens really is. And it was made in 1873 or 72 by the Alvin Clark and Sons firm. And the only defect I could see is a very, very, very faint central zone of about 7 or 8 inches in diameter where the tools were being used when they were polishing it. And that was probably less than a quarter wave easily. So I got to thinking, that looked really almost perfect to me. And that was very encouraging. Of course, I knew it would be a very good lens, but I had to see it for myself. Oh, sorry about that. This thing keeps falling. I'll just hold it. It's kind of like we were talking about earlier. You want to know the why and the how. And so I wanted to verify for myself that this was a really good lens. So I went online and I did some research, and I found out there was certainly enough testing done in the early days of the lens and showing that it does meet the Rayleigh criteria of a quarter wave. And that was a good thing because it was used for high precision photometry or parallax work in its early days in 1870s, 80s, and 90s, and early 1900s. It was a photographic telescope. It used a 5x7 glass plate, and they actually would measure stellar parallaxes by guiding the telescope. Well, technically, they don't guide this telescope. So how do you guide a 26-inch f/15, 45-foot long tube telescope? How do you guide that without auto guiders and without really precision right ascension and declination motors on the mount? The mount, by the way, is the original mount that came with this telescope too. So the guiding was actually done by using a micrometer plate holder that had screws in rectilinear manner so that you could move the plate very, very slowly in one direction and then at right angles to that direction by these 2 drive screws. And then you looked at the star images in live time on the plate as they were being recorded. And you guided the plate. You didn't guide the telescope. So that's how the professional astronomers back then got really nice, sharp images on the telescope by guiding the plate, actually. So I thought, well, okay, that brings up the next obvious question. Well, how much periodic error is there in this mount? And so I said, I know how to do that. I can figure that out. So I began taking some images with my CMOS camera and exposing them for several minutes, or taking a series of multiple images and then stacking together. And you could get the kind of little wobble back and forth of the periodic error. And it's not much, actually. I was surprised that it looks like it's maybe 10 arc seconds or less, actually, at the most. And sometimes it's even less than about six or 5 arc seconds, which is incredible. I mean, I thought, this is a mechanical 150 telescope, and yet it's tracking pretty darn good. So the bottom line was I can image 30 seconds with an ASI 120 camera at the prime focus and get pretty round stars almost every time. So Jerry, can you share the image I took? Speaking of the ASI 120, can you share the image of M15? There we go. Let's zoom in on that. So this is, yeah, so this is a binned 2x2, and that's a binned 1x1 image of the core of M15, the globular. No guiding of the telescope. That's using Sharp Cap. I did a series of exposures that were 1 second long, and I stacked about 650 of them. And that's the image we got. And the goal was to try to capture the faint little planetary Ps 1 that is known to be in the globular. There's only 4 of them that we know of that contain actually planetaries. So I was somewhat successful and somewhat failed. I failed because I could not actually capture the faint nebulous envelope, which is only 1 arcsecond diameter. However, I did capture the central star quite easily. And that's what that object is that's highlighted at the lower right-hand corner. That is actually the central star of Ps 1. And I think if I had used colored filters, if I did an RGB image instead of just a monochrome, I might have been able to see that star looking kind of pinkish, and therefore being much more convincing that we captured that particular nebula there. So that was taken just on Sunday night, just a few nights ago, actually. So the real reason we were down there, though, was to get really nice images of trying to get images of the planets. And, visually looking through this telescope, when the seeing is good, it's spectacular. The view of Saturn that Jerry and I got on Sunday night was the best view of Saturn I've ever seen in my life. We could see multiple bands of the cloud bands on Saturn with this telescope, and the rings were just tack sharp, with Cassini's division being traceable visually almost all the way around the rings. This is an image we took sticking that same night. We stuck our friend Boris and Jerry and I stuck this, and Scott stuck this monochrome CMOS camera at the prime focus of the telescope just to see what we could get. And I was really impressed with how good it turned out, considering that this telescope was never meant to be used like this. It was never meant to have a CMOS detector that has infrared sensitivity and blue sensitivity and green and red. And these focus, this lens, as good as it is visually, and it's beautiful visually. We could see Titan as a globe. It was an orange globe with this telescope, that night. Nice. This image was prime focus, though, and surprisingly turned out pretty well, considering that there's a large amount of chromatic aberration. In fact, I measured the blue and the red focus differences is like a third or half of an inch. So you're cranking this wooden knob at the end of the telescope a good, maybe quarter turn to get the red focus in, and then a quarter turn back to get the blue focus in, right? And so we thought the best way to get images with this telescope to kind of show what this Clark instrument can do is to use monochrome camera with filters. So I humbly inspired a number of people in the Charlottesville Club to start taking images through this telescope using their iPhones, using the club webcam. And so I think I've started something, and I'm really glad to be able to say that there's more people that are interested now in recording using modern imaging techniques what we can see through this antique telescope. And it is challenging because of that chromatic aberration. It's really not as easy as you would think, but we're making progress, and our images are getting better. We're trying a different number of cameras. We do seem to get the best results with the monochrome camera with colored filters, and then stacking, creating a tricolor or RGB composite. That does give us our best results. But this particular picture of Saturn here is the one that they took, or is that no, that is the one.
phone. That's your phone.
That's my phone. Yeah. So here's what you can get through the telescope by just taking your cell phone and holding it up to the eyepiece. I used a iPhone SE, and this was taken using a 20 millimeter Nagler, and on that particular telescope that gives a little bit over 500 power. And then I just snapped a picture. I mean, this is just afocal snapping a single frame of Saturn. So it doesn't capture anywhere near what you can see visually, but it still looks pretty good. And considering it's just a really easy way to take a picture of the planet. So I'm trying to get people in the Charlottesville Club and other people in the Rappahannock Astronomy Club and MSRO to, just think about just using their iPhones and their cell phones to take pictures through their telescopes. And if it's the moon and planets, it shows pretty good. Jerry, can you pull up some of the lunar images that we got? Or actually, can you show the video? The one with you talking?
I can show the video, yeah.
I'm going to let you guys watch this video. And here's the amazing thing that this video captured. This is just a...
If you would, Myron, have Jerry unshare for a moment.
Okay.
And then when he shares, he needs to turn on system sound. Okay, if there's audio there. It's in the lower left hand. Before you commit to sharing, you select something that says share system sound.
Oh, okay.
You see that?
Can you still hear me?
You're still kind of...
Not too bad?
It's bad, but...
We can hear... I got my hearing aid turned up.
I'm losing... Hold on. System sound, is it under more? Share screen.
And I'm on my iPhone, so I can't help you.
Yeah. See what here.
This is for sharing. I mean, if you're going to share like a video that has sound.
Well, the sound, I can comment and what do they call it? Comment. I can be a commenter on the video.
Okay. All right. Then just go back in and share it.
Share sound is on.
Okay, good.
Turned on,
then it
so.
should be good. I just wanted to make sure of that.
Let's play the video in its entirety. And what I'll just tell you in advance, it's going to show a number of moons. So I exposed my phone to overexpose the planet because I wanted to see how many moons I could capture. I was seeing a whole bunch of them visually, and I counted like 5 or so, or 6. But there was one capture that I didn't see visually, even with my looking at the planet as sharp as tack as those moons looked, and how good the seeing was. I missed this one moon, but the video caught it, and just barely. I want you guys to see this because it's very, very. It's the first time in my life I've ever seen this astronomical object. It's the smallest moon in the solar system that has a round shape that's spherical. It's also been the study of recent research that shows it actually may have a subsurface ocean as well, like Europa that might on Jupiter. So let's zoom in on this.
Can you see my screen?
Yes.
Okay. I'm going to start the video over.
No, that's not the video. That's not the one. It's the one that shows Saturn really overexposed.
That's not it?
That's not it. No.
Oh, okay.
No, it's the one of the last ones I sent you. It's Saturn shows really bright, and it shows all the moons around it, and you can see the chromatic aberration as a blue fuzz around the planet.
Okay.
But there's like a bunch of moons all around it. See if you can pull that one up.
So these are the files you sent me. Can you see that?
Yeah, I can see that. I might have sent you the video on your phone. I didn't email the video. I sent it. I think I sent it on your phone. That might be a problem, isn't it?
Well, it might take a couple of minutes for me to transfer it over. I gotta send.
That's okay. Let me just if you want to try that, but I'll describe what we saw. So, So this particular video, as I was watching it, I was like, I see all these moons. I went on my program and I identified Tethys and we saw, by the way, Tethys come out of a shadow or behind the planet. I'm not sure which one, because in one video that I made, it wasn't there. And about half an hour later, I took another sequence to the telescope, the eyepiece, and there it was. It was in the gap where the ring shadow ends before it touches the globe. So So it appeared either because it was just really close to the planet, maybe it was transiting in front of the planet, or maybe it was in a shadow behind. I don't know. I haven't had time to really research that. But my attention was drawn to a faint little tiny spark of light at the right edge of the rings that I didn't notice visually. And I wasn't sure I saw it at first. So I kept looking at it. And then I basically was able to confirm that it was there. And it was the moon Mimas, the closest moon of Saturn. And it was actually recorded on just by holding my phone up to the eyepiece, and I could see it as a faint little tiny spot of light at the very edge of the rings there. And that's how powerful this telescope was. I mean, the rings aren't even edge on, and we recorded Mimas with an iPhone, casually holding it up to an eyepiece, looking at the planet Saturn at 500 power with a 20 millimeter Nagler. So I don't think I can share my screen. There's no way that I can, is there, on this iPhone? I don't know either. But so that was the highlight of that video. And what I could do, if we can't get it here tonight, I'd be happy to join you guys maybe the next one, and just to kind of give you every now and then a presentation of what we're doing with this gigantic refractor. And so here's the view of Jupiter that we took. You can see that one right there. That was again with an ASI 662 MC color CMOS camera, uncooled. We just stuck it into the telescope and focused the best we could, and voila, there it is. And by the way, it shows the exact same face of Jupiter that 9 days earlier was impacted by an asteroid. And so these Japanese astronomers were able to capture on September 28th, I think it was, an impact flash. And so I made sure I imaged the same face of Jupiter to see if there was any remnants in the cloud tops of that impact. And as far as we could tell, even with this big telescope, we could not see any effect other than the normal Jovan type of cloud features. So if you scroll down a little bit more, Jerry, we do some lunar imaging. This is the crater Poseidonus. And that was a really good night too. The seeing was very good there. Again, you can't really, it doesn't look much different, I guess, probably in this presentation than it would with an amateur telescope. But when you're looking at it through the telescope visually, and when you look at the raw data on these images, it's spectacular. And I don't know if we can zoom in on those at all, but probably not. But can you go down to the one do you have the Plato crate? Okay, here's the lunar limb. This is the lunar North Pole. I kind of like the perspective here because it looks like you're in a spacecraft going over. And these images aren't that much really probably better than what you can get with a really good amateur telescope. But we're getting them quite easily, without any skills and without any effort, because the aperture is so large and the focal length, which is 9,900 millimeters, is so long. Now, this is this is actually Eastern Mare Tranquillitatis, lunar Eastern Tranquillitatis. And what you see here are these two domes, and they have on the domes, I don't know if you can zoom in, Jerry, but they have little summit.
Let me see if I can open these.
They have a little tiny summit craterlet on them, which was resolved, which is really cool. And the cool thing about these lunar domes is they are actually volcanic features that disappear once they get too far from the terminator, because the lighting, they're very shallow. They're mounds they're only about like a degree. The slope is only about a degree. So if you were walking around them, you almost wouldn't even notice them in real life if you were there, because they're so shallow. But they're visible at the time of lunar sunrise and sunset. And we happened to catch that time with this telescope on this night. And I was able to get some really nice images of these volcanic rills. That streak at the top is actually a scarp. So it's actually a fault where the local terrain dropped down and created that kind of that fault. And you could see it just basically, with your eye looking through the telescope as if you're almost like in orbit around the moon. The view, I can't stress how incredible the experience was visually looking through this telescope at such immense power and resolution. It was just the most ethereal lunar experience I've ever had observing. And I'm just trying to capture that essence visually that I get in these images, and to share them with as many people as I can. There we go. Beautiful. See how you can see those summit crater on that one right there. You can see the summit pit.
Oh, yeah.
And and that is just, it was fascinating to see that. And I've never seen them so clear. These are little lunar volcanoes, actually. Thank you, Jerry. That's awesome. That's beginning to show what we were kind of like seeing visually there. So, and that bright line at the top is a scarp that is lit up bright like this at sunset, lunar sunset, and it looks like a dark line on lunar sunrise. So this was taken when the moon was a waning gibbous, just about 2 days or 3 days after full moon. Do you have the Plato image that I took on there as well? I sent that. See if you can pull that up. Plato was imaged the same night. It was the sun was much higher up, but I was amazed at how much detail we could see. There it is, beautiful. Can you bring that in full resolution on that? Yeah. We were able to resolve, I mean, like 6 or 7 craterlets on the floor, and they actually look like craters. They're not just little spots. They look at 3-dimensional craters. So I'm going to ask Jerry to kind of zoom in on that. This is my favorite image of Plato I think I've ever taken. And again, this was created using the ASI 662 MC camera. And then I import that AVI file into Auto Stackert, and then take that stacked image into Registack 6 and use wavelet sharpening. And that's all I did and to get these images. So it was really pretty easy, no-brainer kind of processing that any of us could do here.
That's great.
There's Plato.
So what I'm hoping to do with this telescope also is to start using it for making animations of visual binaries that have really short periods. So you can imagine the separation is very small. And I'm using a book that I got. It's observations that were made at Yerkes by S.W. Burnham. And he has thousands of double stars in there that he was using the 36-inch Lick refractor for, and also the 18.5-inch Dearborn refractor. So I figure I got a 26-inch refractor access to that. I should be able to get some of these targets and image them. So I'm going to do that as a multi-year project. Some of these orbital periods are only about a year or two, but the separation is like a 20th of an arc second, which is going to be really, really tough to get with this telescope. But some of them are like a quarter of an arc second, which should be doable. So, and they have periods about 5 to 7 years. So I'm going to put some videos together, which I'll share eventually, which will actually show orbital visual binaries in motion. So stay tuned for that. That's all I have. Okay. I would be happy to see you guys again anytime to show you the latest that we've got that Jerry and I are getting, and continue to share results with this beautiful telescope.
Thanks so much, guys. Thank you.
Yep. Thank you.
Okay. All right. We thank you again, Jerry, for coming on. So
sure, thank you.
We were going to have a 10-minute break. We're running a little bit over here, so we're going to skip the 10-minute break, and we are going to go straight to our next speaker, and that would be Ron Breacher. Ron, thanks for coming on to Global Star Party. If Ron is here. Here he is. There we go.
Hi there.
Hey Ron, how are you?
I'm great. I've been watching from upstairs.
I see.
And was going to come down during the break, but I just dashed down the stairs.
We're running way over at this point, so I thought let's just go ahead and.
Oh, that's fine with me. I'm ready to go when you are.
All right. So you're going to talk about a few of your favorite things.
Yeah, and
you were getting a little teased about that.
Yeah, well, I
hey,
did.
I'm with you, man. So.
Steve Malia suggested that I sing it because
I love to hear that.
From Julie Andrews. Yeah, you're not going to get that tonight.
No, not tonight. Okay.
We don't know each other well enough. Me and all the people out there.
We'll get there. We'll get there.
We'll get there with time.
Yeah.
Anyway, look, let me share my screen with you, and I'll get right into it. Last week, I talked about overlooked objects. So this week I wanted to talk about sort of the other end of the spectrum for me and show you some of my favorite things. So thanks again for having me to the Global Star Party.
Thank
And
you.
you know, Scott, when you send out those invitations, you always set it up with a theme.
Yes.
And I always read those. I don't know if everybody else reads them. I read them and I think about how can I say something that might fit in with that theme. And I just want to show you that this is what Scott sent this week. I don't know if everybody else read it. I thought this was really inspirational, particularly the second paragraph for me. The idea of how vast the universe is, and you know, we can just explore the universe. So that's what I want to do in this talk. But instead of going after the overlooked objects, I'm going to indulge myself in some of my favorites. And I've been imaging, seriously imaging, for about 10 years now. Sorry, 20 years, I should say. But it's really in the last 10 years or so that I've been publishing my pictures. And I started my website in 2014. So these are some of my favorite photos. And I've got some photos in each of the categories of deep sky object that I tend to shoot. So first of all, open clusters. This is the wild duck cluster M11. Actually, when I was talking about overlooked objects last week, I had a comment in the chat box from somebody who said, surely you're the wild duck cluster is one of your overlooked clusters. No, it's not overlooked. Lots of people shoot it. It's a beautiful place to target because it's got these beautiful dark nebulae that you see to the upper right and actually the whole right side and to the upper left. So that's one of my favorite open clusters. And here's another favorite open cluster shot. This one I took back around, I think it was back around 2012 or 2013. And it's been published all over the place. It was in the Sky and Telescope calendar. It was in the ASA calendar the first year I had my ASA 10-inch scope. And the beautiful diffraction spikes on these stars are from the design of that telescope. Astrosystems Austria make beautiful reflectors. They don't make them in this size anymore. So if you come across a used 10 or 12-inch ASA reflector, go for it. You don't often think of the Pleiades as an open cluster, but it is, and especially if you look at it with the naked eye. It's fantastic in every kind of instrument that you could look at it in. That includes your naked eye, low power binoculars, high power binoculars, a small telescope, a big telescope. So I shot this with that ASA I was talking about, and all the red circles encircle locations where there are little galaxies. So this one right here has a little galaxy in it. So there's stuff hidden everywhere. You just got to look for it. Globular clusters. So I have a few friends, Sean Nielsen, Gord Simpson, a couple other people who tease me because I really like globular clusters. They say they all look the same. I don't think they do.
No.
I don't think they do at all. In fact, there's a scale for globular cluster density that differentiates them. And here's three of my favorites: the Hercules cluster, M13, and then what I like to call the other Hercules cluster. It is a kind of an overlooked object, but not by me, Messier 92. It's probably, you know, I might like it better in the eyepiece than M13. And maybe the best northern globular cluster of all, Messier 22, which when you look at it in the eyepiece, you see it doesn't really look round. It's kind of got sort of a eggy, oblong kind of shape to it. Anyway, they're all different and I love them all. Molecular clouds. So these are these areas that have these kind of light brownish nebulae, and this particular region called the dark shark. I think you can see him. Here's his dorsal fin over here, and his eye, and he's got his mouth open, gonna bite you. This has all kinds of other really cool features to it. Some beautiful blue reflection regions over here, down here. The dust that's everywhere gives these lovely halos to the stars. And over here, kind of hard to see, but there's a really pretty little galaxy. Go to my website, look for the dark shark, and you'll be able to zoom in on that little galaxy. And here's a cosmic salamander, another one of these regions that's got some of this cosmic dust, molecular cloud. The red is from hydrogen alpha. I just love these kinds of objects. There's other really famous ones like the Parrot's Head Nebula and so on that I haven't imaged yet myself. I'll be going after those as soon as I can. And this is the Angelfish Nebula, sometimes called the Rotting Fish Nebula. One of my favorites of these kind of bright, dusty regions. And let's move on to Emission Nebula. This is Orion's Sword. I think it's got to be one of everybody's favorites.
Oh, yeah.
This has always been a favorite shot of mine, and I took it a long time ago. You can tell again from those diffraction spikes. This was taken probably around between 2013 and 2016 or so. But I had a huge honor late last year having this photo chosen for the cover of the 5th edition of Night Watch. And just today I received my copies, 2 copies from the publisher. And I know Terence Dickinson, this was one of his favorite photos of this region, and he had a hand in choosing this. So quite an honor for me. More Emission Nebula. This is cool little series of images because we're gonna see this up close and personal and in a different light. So this is the North American Nebula on the left, and on the right you can see the Pelican Nebula. Although I think it looks maybe more like a pterodactyl than a pelican with this crown on the head. And my wife pointed out to me about 5 years ago, my wife Gail pointed out to me about 5 years ago, this little lizard head peeking out of the cave here. And once you see that, you can't unsee it.
That's right.
And there it is. There it is, up close and personal, taken with the new 14-inch Edge HD Celestron Schmidt-Cassegrain that I've been using. And I mentioned the Pelican. Here it is in a different light. This is the Pelican Nebula in Hubble palette. So for those of you who aren't familiar, the Hubble palette is really a color mapping technique. You shoot with a black and white camera through filters that pass the emissions of very specific elements. So sulfur, hydrogen, and oxygen are used in the Hubble palette. Sulfur is assigned to the red channel, hydrogen to the green channel, and oxygen to blue. And then you mess around a little bit with it and throw in a little bit of magic, and you come up with some really amazing, beautiful images that not only reveal structure, but they reveal differences in the gas composition. So I can't tell you exactly how much hydrogen, sulfur, or oxygen there is at any specific spot in the image, but I can see where it's changing. So I can see that in this area that has a green tinge along here, that the chemistry is different than this orange region over here. I don't know exactly how they're different, but I know that the gas mix is different. Oh, and by the way, there's my little lizard head again.
That's right.
You can never unsee that lizard head. Another really famous emission nebula, and one of my favorites, is the Bubble Nebula. This time I'm just showing it in the Hubble palette. So this little bubble over here is being blown out of the gases in the region by this Wolf-Rayet star, the bright star at the edge of the bubble there. And if you look at the lower left of this image, this sort of bluish structure here, that is my imaging target tonight. And I'm shooting it at very high power. It barely fits in the field. So I'll be sharing that with you in the coming days.
Great.
Dark nebula. So these are areas where dark dust blots out the stars in behind. And this is the Seahorse Nebula, Barnard 150, one of my favorite dark nebula. I've shot this a few different times. This is probably my favorite image that I've taken of it, although I've seen some great images of this region by other people. By all means, go out and get it. This was shot with a 4-inch refractor and a full frame size sensor. So easy to get with relatively small telescope. Another really famous dark nebula, actually there's a couple of them in this image, but the most famous of course is the Horsehead Nebula. And as you look at this very colorful image, it would be easy to mistake the Horsehead as some kind of an emission nebula. There are lots of emission nebulae in this image, but the Horsehead Nebula is actually a finger of dark dust that's kind of billowing upwards and blotting out the light of the stars behind it. So it is classified as a dark nebula. And you'll also see a dark nebula running through the core of the Flame Nebula, which is on the lower left of center. Planetary nebula. Everybody loves planetary nebula. Again, I shoot the dumbbell with every type of equipment that I have. And I was, again, if you look at the diffraction spikes, you might recognize that ASA telescope. This was taken in 2016. And it featured on the August issue of Sky and Telescope on the cover, my very first cover of Sky and Telescope. And supernova remnants, of course, the Crab Nebula. I love all the tendrils and fingers in the crab. And again, you can tell by the diffraction spikes that 10-inch ASA, boy, it was a real keeper. The Veil Nebula Complex, very challenging to get with a moderately sized telescope because it is so big. This is actually a mosaic, a two-pane mosaic, two-panel mosaic. So the top half and the bottom half were stitched together, but more than that, I made a top half with 2 different filters and a bottom half with 2 different filters. And so I had to combine all the data to reveal the red hydrogen, and mostly hydrogen, some sulfur emissions, and the teal oxygen emissions from this supernova remnant. Galaxies. So boy, galaxies might be my favorite kinds of objects of all, and I can't show them all to you. So I just picked a few. This is M101, the Pinwheel Galaxy. Shows lots of fine detail and lots of faint structure. If you can go long on this, go long on it. This is Messier 33. Another beautiful galaxy that's worth spending a lot of time on. One of the things that's tough when you process this galaxy is to avoid it looking really flat. And so you have to kind of work hard to make the core pop a little bit without burning out. Love this.
Are you trying to get back into bowling?
And of course, I would have to put in the Andromeda Galaxy. This image was taken in 2020 with a one-shot color camera, but I actually just processed it a few weeks ago live on Masters of PixInsight. So mastersofpixinsight.com. I teach with Warren Keller. We do video tutorials and video workshops as well as video tutorials. And I processed this live in a Photons to Photos workshop. This is how it came out. So again, one of my favorite galaxies. So also in the category of favorite, I have to put in favorite because it's new. And I acquired these. I'm going to show you a series of 3 photos of this object. I acquired it last night and the night before. I got some of the RGB the night before, but most of this was acquired last night. It was finished last night for sure. So this is Sharpless 2 188. It's sometimes called the Prawn Nebula or the Shrimp Nebula. I've heard it called the Dolphin Nebula. If you rotate it 100 degrees, apparently some people see a dolphin jumping. This is natural color RGB enhanced with hydrogen alpha to make the red pop. The stars are natural and the background is natural color RGB. But I went ahead and I shot this in a couple of other palettes. So this is called the 4-Ax palette. And again, because this is all narrowband, it reveals areas where the gas compositions are different and changing. So I think that's really cool. And I also processed it in a traditional Hubble palette. And there it is, showing some really nice yellows and vibrant blues and even some greens. Greens are okay in narrowband. Well, thank you very much for indulging me. That's all I've got to say. I try to keep these short and sweet because I know you got some great speakers and want to make sure there's time.
You're one of them, so thank you. Thank you. That's great. Okay, so we are moving on to our next speaker. Ron, thanks so much for your kind words.
See you later.
Yeah. Okay. Let's see. Our next speaker is, by the way, Ron is also known as AstroDoc, and so you'll see him. I think you can go to astrodoc.com or CA.
Astrodoc.ca, proudly Canadian.
CA, Canada. That's right. All right. Thank you. All right. So we're moving down to Brazil to Marcelo Souza. And Marcelo, thanks for coming on to Global Star Party. What are you bringing to us this week?
Hi, nice to meet you, all of you. Thank you very much for the invitation, Scott.
Thank you.
I will show some experience that I had with the observation of a solar eclipse. As now here I'm working all the day in preparation for the observation of the partial eclipse, solar eclipse that will be possible to see here in Brazil, in most of the Brazil. In the north region of Brazil will be annular eclipse, like you see also in the United States. But I will share some videos that I recorded from my first observation of a total solar eclipse, and also one of the observation of a partial solar eclipse here in our region in Brazil. This was, I'm showing first the World Cup because it is associated with my observation of the eclipse. This is the stadium of the final game of the World Cup of 2010. That happened, a game between Netherlands and Spain in 2010 in this stadium in South Africa. And the game happened here for us in South America, Brazil, Argentina, on July 11 at the end of the afternoon, almost the end of the afternoon. And at this moment was the moment that we observed the total solar eclipse in the south region of Argentina. Then when I arrived there was for me a fantastic experience because I arrived in the city of El Calafate, that's in the south region of Argentina in 2010. I was with my wife. We arrived in the city and I imagine you have few people there. I can observe the eclipse, but when I visit the first hotel, it was full with a lot of people waiting for the observation of the eclipse. And as in front of us, we had the Andes mountains. Right? We needed to go to a mountain 1,000 meters high to see the eclipse because it's happening at the end of the afternoon. I will show the video that I recorded when I was there. First of all, it's not a professional video because I was with my support for the camera, but as it was not to work in the beginning of the eclipse, then I quit everything only to see the eclipse. When the eclipse began, I tried to record and work it. Then was in my hand, then was shaking. I'll show now. Then this was the eclipse of 2010 in the south region of Argentina and Chile that was possible to see. Here is the region where I was here in Calafate. That is, it was a total eclipse there, also almost in the middle of the totality of the eclipse. Né? Here, and here is the video that I recorded. This image was in a hotel in Calafate, where you have a private company that organized a trip to see the eclipse. And this happened, the eclipse, we saw the eclipse during the final game of the World Cup. Right? At the same moment, the final game of the World Cup. Between Netherlands, I was in the top of the mountain to see the eclipse during the game. I will show here the video. I will put here the music. From the south of Argentina, the music. Here we are at the hotel. There was a presentation at the hotel before the beginning of the eclipse. And here it was very cold, very cold. The temperature was -4 degrees Celsius, but we feel like less than -15 degrees Celsius in the top of the mountain. It was very cold, with a big snow, almost 70 centimeters of snow in the top of the mountain. And it was very cold, very cold. I need to go there because I will show in this video where is located the mountain. The Andes mountain in front of us. This is the Lake Argentino in Calafate. And here's the mountain that we need to go to the top. Went to the top of this mountain to see the eclipse because it was in the end of the afternoon. Then you have the Andes mountain in front of us. Then I need to go to a mountain that the high is 1,000 meters. Here is the top of the mountain where we are prepared to see the eclipse. And it was the only place that you found a possibility to go to the top because all the other places were full of people. The eclipse now.
Wow.
I recorded the eclipse. And at the end, you can see the ring of diamonds. That's a special moment at the end of the eclipse. For me, it was a fantastic experience for me. This is the music from the south of Argentina. I forgot the name of the singer. In a few minutes, we are going to see the ring, the fire, the ring of fire, diamonds, the ring of diamonds at the end of the eclipse. So it's fantastic for me. And it's shaking because I was with the camera in my hands. And it was, the diamond here. It's a fantastic image. And I will show the city of Calafate without the lights on. Here. The city of Calafate there. Without the lights on. And here is my wife, like a Taliban. Only her eyes you can see because it was very cold. This was for me an unforgettable experience. It was a fantastic experience for me. And Spain won the game. But I only knew about this after the eclipse because I had to stay there for 1 hour, 2 hours after the eclipse, waiting the transport to go to return to the hotel. It was a fantastic experience during the last game of the World Cup in 2010. The other experience here near us was this. That was an eclipse in February 26, 2017. That was also in Chile, in the south of Chile and Argentina. But for us here, it was possible to see 30% of the sun covered by the moon, almost this. No? But we recorded this. We organized an event, and it happened during the carnival. Sunday, I think that it was Saturday or Sunday during the carnival here. And a lot of people participated to see the eclipse. We made a campaign here, and they didn't believe, but during the carnival, we're going to see the eclipse. And what I can do? And here is a report that I showed in the Brazilian TV of our observation of the partial solar eclipse. It's another fantastic experience. It was in another city near us, that is São João da Barra. Another city. There you show the images. We were there. The partial solar eclipse here. Have some clouds. A lot of people visited us there. You have 6 years that was possible to see the eclipse, and it was transmitted for all our states. Our experience to see the eclipse. Now we are going to do the same thing that you did in this time, but now we are organizing the observation in 20 different cities at the same time. It will be our first experience to organize so many cities at the same time. We are creating here a headquarters to coordinate the observation of the partial eclipse of the sun. Here you go to see the maximum of the partial eclipse. At this moment will be more than this. Here probably 30% you have clouds. They are showing what happened with the birds at this moment, but it wasn't dark. Here's the maximum of the eclipse at this moment, 2017. It was a fantastic experience with the public here. And now, I hope this time we have the opportunity to have so many people participating in the eclipse, the observation of the eclipse. It is a very long report. Here again, the partial eclipse. It's just fantastic. And now for us here, it will be like this time. Né? And if the weather help us in the day, because today it is with a lot of clouds, it is raining. We are concerned about the weather for the eclipse, but even with this concern, we are organizing the activity for the eclipse. We are going to have the support of the Stephen Hamsden. We have glasses to give to the people. We have 6,000 glasses to distribute free for all the people that you see the eclipse here. And we are planning to organize a big event. And last week, we finished the preparation, the first activity for the preparation for the eclipse with the planetarium, mobile planetarium here. And we had the participation in 4 days of 2,000 students that participated last week. And also we had the observation of the sun with a lot of, in 3 different cities. It was a fantastic experience. And in 3 months, we organized many events here. You had a total participation of more than 4,000 people that participate in these events in 3 months. Only last week, we had 2,000 people because of the planetarium and the other activity that you organized. And this week, we have Thursday and Friday an event, Saturday and Sunday, the NASA Space Apps, and next week, we'll be involved directly only with the organization of the eclipse. Then, Scott, thank you very much for the opportunity.
Thank you so much, Marcelo.
We
What a
are doing our
fantastic
best
view.
here.
What a fantastic view of that that eclipse as it was grazing the mountains there. I can't imagine seeing an eclipse so close like that. So it was beautiful.
For me, it's unforgettable
Beautiful.
experience.
Yes.
Unforgettable.
Well, for all of those people out there who have not seen a total eclipse, you have to go see one at least
Yes.
once in your life. It will change things for you. You will change inside. Your mind will change. So, and there's, you can't, gosh, you really can't describe it very well, you know, so, but,
Thank you very much, Scott. It's a great
Marcelo knows
pleasure
what
to
I'm
be
talking
here.
about. Thank you very much.
you.
Okay, all right. Up next is Adrian Bradley. Adrian, are you with us? There he is.
I am, but there might be a lot of background noise. Can you hear me over the music playing behind me? And I'll explain why
hear the
I'm
music.
here in a minute.
Adrian.
I hear that.
I just got done bowling, didn't do too well, and so I've moved into an arcade to do my presentation. So with the backdrop of an arcade, we're going to go into Uncharted Cosmos. And the theme I decided to pick was, and I'm just going to use desktop, different ways to get images of the moon. I saw some moon images earlier, and what I wanted to do was share some of my challenges that that I have, because moon imaging is a little different. You see some of the Milky Way photos I have here, but you know, and then some others. But what about the moon? There are a few challenges that I put for myself, and I extend them to those that like to take images of the moon. And the first challenge would be Earthshine. Taking pictures of the moon using Earthshine. It can be beautiful if you pull it off, and I'm sure I'll have a couple more images of that later. But and then reflections as well, if you can do that. The other challenge is getting the moon with the Milky Way. As you can see, there's some work that I would need to do to process this a little better. But that is a huge challenge for those that like to image the moon. And there's a couple different ways that we can do it besides just simply taking pictures. Now, most of the time when we do moon images, the moon is blown out and you have your scene, but your moon is blown out. One of the challenges is to take a picture of the moon where there's detail. This is something I try to do a lot. And as you can see, this particular image, I had the help of clouds, but it's still rather dark here. You can see the lake, but the fact that we got the moon with detail on a single shot is very much a challenge for anyone that likes to do moon photography. Let's go to this. Is another version of the moon with the Milky Way. This is moonrise. This is the sun is going to rise as well, and the Milky Way is fading. Getting the moon and the Milky Way in the same frame is a challenge. I've seen Alan Dyer do it during an eclipse. So speaking of, a couple others. Moonlight, using moonlight to take a photo. So the moon doesn't show up here, but its light sure does. And you pull that light in and you're able to illuminate almost as like daylight, but with a longer exposure. That's why you see the clouds shaped the way they are. So that's always a challenge, just using moonlight itself. Now, when we get a rising moon, it often looks like this. But John Schwartz knows the image that I'm going to look for. And that is, before I do that, getting the moon during an eclipse is always a challenge because there's the moon in front of the eclipsed sun. Total eclipse, I've seen some really beautiful shots. Here's a challenging one for you. Moon and clouds, but the moon is sharp. That one, you have to make sure, if you're using autofocus, you make sure your dot is on a part of the moon and not the passing clouds.
Wow, I got one just like it.
Yep. I knew you'd have, I saw.
I mean, it might be the same one.
Yeah. So that is a challenge for those who like to capture the moon. Here's another challenge. Capturing the moon the way our eyes see it.
That's
Here we are at
beautiful.
blue hour, we're at moonrise, and this is the moon the way we see it. And notice with my processing, I took out a lot of the bright glow from one of the images. These are usually composites. When there are no clouds to block the moon is simply too bright. So doing composites tends to be the way to get a shot like that. We all love the close-up moons where we've got detail. I'm not sure if I can zoom in or not. I'm going to try, but I don't have my mouse with me. But you can see here, and this is the moon that we just passed. Right now we're at the moon where it's waning. It's about here. Anytime you can use a camera or a telescope and you can get your close-in moon. Let's look at a couple of other examples. This is a tough one. Moon rising in the zodiacal light. I'd love to see some images out there. Those of you that live in dark enough sites. And in September, the zodiacal light in September, this is M44. The moon rises while the zodiacal light is still visible. I'd love to see some images of that, especially if I have, let's see if I have it here. I don't. There's an image of Orion, this image here, but with the zodiacal light making a cross. I know it's somewhere in my group of images, just not here. But having that and the moon. This is lunar X and lunar V. There's the X, there's the V. If you catch you catch first quarter at a certain time, these craters, the shadows and the craters form what looks like an X and what looks more like a V. The X looks like it forgot something over here. The little stem over here isn't quite as long, but this is these craters form an X when the shadow, the rising sun hits it just right. That's another challenge. All right. I'm going to. There's only 6 there because. That's right. I lost the bet with my one of my teammates, so I didn't win all of the money in that last game. So let's couple more moons before we turn it over to Schwartz and his beautiful drawings. An eclipsed moon. It's worth taking a picture of an eclipsed moon because of the way it looks. A lot different from a regular first quarter. You see the shadow eating the moon away. Most of the time, people look at this, this is when it was 97%. I've got a couple more that are 100%, but let's show it in different places along the ecliptic in the sky near the Pleiades. It's a good way to show eclipsed moons. And we'll skip through some of the styles of moons. This is a daytime moon. Capture the moon in the daytime or at dusk and see if you can get that detail with the sun shining on it. This is a challenge. A lot of folks get the moon looking like this. Let's go to total eclipse. I used what I had. There's mountains. There's an eclipsed moon peeking through clouds. Sometimes you just have to use what you've got. Earthshine moons. Here are some more Earthshine moons that I took. And the nice thing about the Earthshine moons is you basically get a full moon if you expose long enough. The tough thing about it is this limb extends longer than it should. This limb grows if you do a longer exposure, the moon is moving. So the trick is to get the limb to make this the perfect circle, the spheroid that it is, and yet get more of the full moon. And stars. You end up with stars if you get a pretty good shot of it. A lot of astrophotographers do mineral moons. This one, this little feature they call the golden horn when the shadow is just right. This feature, this rim of this crater sticks out, or I should say this wall, because you can see this is part of the mare here. Crater is filled in. The mineral moons show colors. As it turns out, titanium, this element is really here. Those of you that are following along probably know a little more than I do. These colors represent elements that are really in these places on the moon. Quite a while ago, one of these won an APOD. The colors were accented even more. But mineral moons, shooting the moon through clouds to trying to get the moon to look the way that we see it. This would be a binocular view of this moon with the clouds following. That's a challenge. More moons as it grows. Another Milky Way and moon photo is here. Let's see, I'll try and capture the moon when there's something going on astronomically important and the moon just happens to be a part of the lineup. That is always a challenge. Moon with aurora, I haven't done that one yet. That would be a good challenge for it. So we'll finish up. Here we have another composite of the moon rising over the lake. We have a beautiful picture, but the moon's all starred. Some folks love this, and I don't blame them. It was a peaceful, serene picture when I actually took it. I just laid the camera down on the wild beach. We're going to skip all the way to the later images. Okay, a couple more. Get a nice, clean looking, totally eclipsed moon with a star field. This one shows you, there's Uranus right there. It's one of these two. Uranus does appear right here. There's the moon. And also, what does the sky look like? There's the moon. This is a for a 16 millimeter image, that's how big the moon is in this image. There's your eclipsed moon, and there's your sky with your winter Milky Way and Orion. Depicting the moon as a part of an overall sky is something I'd love to see a lot more of being done. It's a little different. Now, of course, we had the occultation of Mars by the moon, and here it is keeping, I believe this is when it was coming back out. I do not recall which side of the occultation it was on. I happen to have, if you see this dot right there, there's Mars, there's the moon, and that's the cloudiness that I had to fight. So a couple more. Here's one that, if I could zoom in, I would show you, this is a realistic how the moon looks. If you're looking up at this tower and the moon is here, even if it's cloudy, you can still get some very interesting moon photos. So never give up. If it's not clear, the moon is a good target for you. Moon with planet, either Mars or Jupiter, and getting detail on both. Well, when you have a camera, you're not going to get much detail on the planet, but you can still get detail on the moon. And then finally, let's look and see where, see, moonlight affected images like this one. You know, attempts to put the moon on top of something. There are a couple of gimmicks you can do. More earth shine. Here's what I would consider a little bit better earth shine photo. So there are gimmicks, and then there's challenges. Here's a gimmick. You got the moon on top of a tree. You know, this kind of shows the size. The moon is rather large, larger than we think in the sky, to be able to be a tree topper at that size. And then finally, let's just shoot all the way down to blue moons. Whenever there's a blue moon, just take your processing and lower the temperature so you end up with a blue moon. It's a wonderful gimmick. Or try and make a mineral moon out of it, or the way it looks to our eyes. So you can process a couple of different ways. And then finally, toenail moon, as one astrophysicist, Dr. Becky Smethers, calls it, when there's just, we've seen some amazing versions of moons coming just out of the, the very first waxing crescent, as thin as they can get, if you can catch it. And now here we go, last view, a rising moon. This is one of my white whales, is to get as much detail as I can with a moon that's rising. Making this look a little more natural is a goal of mine. Yes, these clouds were here, this glow was here, but one key that I think I'll have is if I turn the opacity of this moon so that it looks more like it's shining through the clouds instead of popping it right on there. Looks kind of like it's blocking an eclipse here, and that's not the effect I want, but something to keep working on. Here we have stars. We have a scene in which the detail of the moon was composited with this overall shot. This is a crater. It's actually heading for this light. And you've got the lights of the crater here, and you've got the moon. There's more work that can be done to get that crater out. It's definitely a challenge. And then finally, you have, once again, when your moon's not completely full and it's a waning gibbous, you see more craters on one limb. Waxing gibbous, you see craters in this limb. And that is where I'll stop. Hopefully everyone was able to hear over the talking. Yes, I won a little bit of money from the last game because of my card hand, but that is where it's at. So those of you that like to do moon photos, those are some challenging thoughts as far as getting different ways that we can see the moon, not just one way, close up or featureless. We can try and image it. We can put features in it. The biggest challenge is to image the moon as we see it in an environment and or see its effects. There are some endless possibilities. And of course, with the total solar eclipse, the annular solar eclipse, it'll be for those that are going to see annularity. Are you able to get detail of the moon in front of that ring? That might be an interesting image. And then totality, of course, there's do you have moon detail that you can get with a good enough exposure? Can you get moon detail in front of the sun and that corona? So challenges indeed, Scott.
Yeah. All right. Well, it looks like you're having a good time out there too. And all right. Thank you very much, Adrian. And enjoy. Okay, so we are
Yep,
moving
thank
on.
you, Scott. I had mute on.
Oh, that's
And,
all right.
John, I'm gonna turn my camera off, my mic off. I'm gonna watch you go, buddy. You're on mute.
You're muted. You're muted, John.
John, you're still muted.
You're still muted.
I'm learning how to do this stuff
There
now.
you go.
I'm getting pretty good at it. So anyway, it's bright in here. This is a beautiful shot from that is Amboy Crater. We were out there. You could see it.
Milky Way.
Beautiful moon on the horizon.
No, this is the Milky Way.
Yeah, Milky Way. Anyway, yeah, it's a great wintertime spot to view from. It's very dark and dry. It's the desert, you know, Amboy Crater. Anyway, let me get started. Adrian, it's good to see you.
Oh, same here.
Yeah, I've got your exact moon there. It's kind of crazy, but let's start it up. I got these sort of in order. I wanted to put them. You know what's weird on Zoom? They're backwards. So you set them up backwards. I'm learning. And we're going to be doing good. Okay. There it is. Look. It's like the same exact shot right. Almost. It's crazy.
That looks familiar.
Yeah, that must have been similar. You know, I've been getting a lot of moon in the clouds lately. It's pretty cool. That one's for you. This was Mount Pinos. Now, this was the last star party in August where the marine layer came in, and it was basically at the base of the mountain. So everything was covered. You can see how beautiful the Milky Way is. And that's my telescope straight in the middle. The 28, the 32 is on the left, and the 22 is on the right. But that was a magnificent night we had. Really nice time. Really dark and transparent. This was one I did from there, the Skull Nebula, NGC 246. It's a real nice target to look at with the 28. It really opens up and you can see a lot of detail in there, especially with that transparency we had. Very nice. I think this has a triple star too, which is unusual. There's my new ring I'm working on. This is, I'm trying to nail it to how it looks in the 28 in the eyepiece. Very eerie color that our eyes pick up, greenish, you know, blue, because our eyes are more sensitive to oxygen than hydrogen. But I'm really proud of this one. I'm still working on it. I can never get them perfect the way I like them, but I'm happy with it. See the double star inside? You're getting a view of the second star. So that was a great view. Crab Nebula, one of my favorites. This one I used some Malincam data to add to my previous, but it's just an amazing thing to look at. Even in the eyepiece, it looked amazing last month, probably better than I've seen it in a long time. This is M61. Again, the Malin cam brings it out like this. I mean, when you do it visually, even with a 28 and a 32-inch telescope, it's not as bright as you would like it to be. Now, if you study it and spend some time looking at it using averted vision, and you can start to pick up some of the detail, the core and a basic round shape with a hint of some spiral arms. But this is the Malin cam unveils the detail. So I made this other thing out of just like a Mount Pinos. Pretty cool. Imagine laying in a grassy field on top of a mountain, and say it was Andromeda was coming in. So in like 2 million years, it's going to collide with us, but you would be able to see this massive galaxy like that. It would just be mind-blowing to see. This is just a quick mock-up I made. I'm going to probably do this in much greater detail.
Cool. I like that.
Thank you. Yeah, it's just like a place, we're always waiting.
I wish I could see it like that.
Yeah, I do too. Although if we can talk to the aliens, they might get us there, get us out for a trip, and we could see it.
If that's what it takes, I'll talk to them.
Please, I just want to go to 51, and that's it. No further.
You don't want to go any further. Okay.
No, because, well, I'm afraid if we do that, when you come back, there may be nothing left. I might have to live out my life with the aliens.
You might.
This is Sombrero. Again, this is how it looks in the eyepiece with the 28. It's amazing. You get a hint of color, and it's such a great galaxy to see with the 28. It's an amazing edge on. Love the edge ons. This is NGC 5907. Now, I added some of the Malin cam detail. My original sketch was similar. It wasn't quite this good, but this is in Draco. It's a beautiful edge on to look at. It's absolutely gorgeous. It's one of the better ones to look at. This is M74. Again, Malin cam is very helpful in getting this detail. It's really helpful to have various tools to, use when you're after a night of observing with the 28. Literally, you can't walk the next day. It's pretty bad. You're on the ladder all night, especially when I'm trying to sketch these things on the phone. My legs and back, everything just goes numb. So the second night, I decided to hook up the Malin cam and just relax, sit down and enjoy the show and see the details that you can really get in like 7 seconds. It's pretty much live. I don't even just contrast. It's just such a powerful tool, and you're seeing in color. What's nice about the sketch is the stars aren't bloated like the Malin cam, but being an artist, I can remove the stars and put them back, much like astrophotographers do. So if you were doing Orion and you were trying to expose the trapezium as well as the whole Orion Nebula itself, you'd have a real hard time because the brightness of that trapezium would burn out the whole image. So you would take that out and add it back later, and you can really get some great effects. Here's my newest Orion. Very proud of this one. I mean, I was trying to get it. I spent a lot of time on the Dark Nebula today. I could just do this one every day. It's like my favorite nebula. Look at the trap, the detail. So this is a view pretty much like right there when I was in the daytime. We were looking at Orion with that filter, and this is like what I was seeing. And what you notice is inside the trapezium and around it, there's like macro clouds. And that was described, I think, by Sir Lord Ross, or was it William Herschel? One of them had said that the clouds were very similar to macro clouds, like sailors, see when they're out at sea. They're like flocks of sheep, I call them, or they're called mackerel is the term. But this is actually how the dark nebula in front was appearing. It had holes in it. I've never seen it with that kind of detail. And I'm not certain if it's because of daytime or if it was the filter in the daytime. You know how Jupiter can be really good at just before sunrise or just after sunset, you still have light. So what happens is you get the colors come out and you get a moment that's really steady. So you can really see the details in the belts and the red spot and some of the best times to view. And it actually works on Orion. I couldn't believe it. Trapezium at 7:05 in the morning, still looking at it. But I really like this one. I have another one I haven't shown.
Beautiful.
Thank you. Yeah, this is years of work, by the way. This is just taking my best rendition and taking it further. I was trying to capture that view. I'm going to hopefully get a shot of it so I could show everyone. And there's my Mars from the Mars transit of the lunar transit of Mars. That was one Adrian was showing. This was actually how Mars appeared in the 18-inch Zambudo Star Master. Very sharp and dusty with a little polar cap. This is Venus in the daytime. I don't know if anybody's ever tried, but I used to look at Venus and find it in the daytime just because I knew, where it was, and you could spot it pretty good with your naked eye when it's in this phase. It's actually closer when it's a crescent, so it appears bright, but when it's 3/4 phase, it's smaller, so it's harder to find. That was actually in the daytime. This was my first publication in Astronomy Magazine years ago. I'm still trying to find out which edition it was, but this was the triple shadow transit of Jupiter, and it was cloudy, and I got so lucky because the clouds just opened up and I was able to get it. I was really happy with this. So hopefully I can get some new ones in there. This was a moon in the clouds. I love this one because the cloud is the way I, painted it. It appears to be right in front, And this was a spell where we had a lot of clouds for a lot of time. So I would just be able to get little peaks of the moon like Adrian. And I have to admit, some of the best views are when the clouds part and you get these beautiful vistas that are just more than a stark moon. Even clouds can be beautiful. So I really like this one.
Yeah, that was part of the reason I started shooting with clouds up, because I'd always, when I got started just trying to learn, it's too cloudy, can't do it, or some other atmospheric reason. And I'm like, I don't want to stop shooting just because of the clouds.
No, that was the thing on cloudy nights. I did one and it was like just after sunset and it was blood red, the sky. And there were streamers, really high cirrus clouds, and they were just draping across the moon. And so I drew it and I posted it, and a gentleman said, I could kick myself. I should have done something last night. Even with the clouds, you're able to do something this good. It was just amazing. And this is just walking my dog. I see these beautiful flowers in the clouds, and the best time of day to capture these kind of pictures is like right after sunset or early in the morning. Those are special times of the day photographically to capture the real mood. And it's just something about that time of day when you take pictures. It's absolutely amazing.
Mm-hmm.
Here's another one.
Beautiful.
And just beautiful stuff.
Yeah, I like flowers too.
I love them.
Yeah.
They're like very, symmetrical, and the shapes. I think the shapes are repetitious in nature, the way they blossom.
Agreed. Yeah.
Pretty crazy how everything is defined by the physics of,
The cosmos is right there.
Yep.
Right? Just close up.
Don't mind the eyeball. I was trying to pose with my dolly paintings. So this is my two paintings that I did, 30 by 40 acrylic on canvas. And I got them framed, so they just came back from the framers and they were bubble wrapped. But there's the other one I didn't show you before. And this took quite a bit of time, not as much as the other one. But if you look in the eyeballs, the other one especially, there's actually veins, pareidolia. Yeah, it's a photorealism. That's what I studied in college. I did graphic arts as well as fine art, sculpture, figure painting,
Yep.
Nude models. Kind of crazy when this one guy, he was like an old sailor, and I'm not certain if he was out at sea too long, but he always liked me, probably because I did great pictures of him. This was just a simple sketch on paper and India ink wash. So one of my exercises and how I would figure paint is I would always start with pen and ink, just a regular little ink pen, and dip it in the bottle of ink and just rough it out. And then I would come in with water, and I would dilute the ink and create different values of monochromatic shading tones to create, this is high contrast. There's very little shading needed, but you can see how the hair, you diffuse the shadows and it gives that effect of floating in front. And then there's a nice core line on the chin. Little techniques, but I actually found this not too long ago, so I was pretty happy with it. Just a quick rendering. And there's my little friend, as usual. He's with me right now. He didn't get to eat because we, again, didn't almost make it. I got so much to put together, and I'm last minute every day. It's crazy. I did a lot of stuff for the wife this weekend, honeydews. So I made sure I did that first, even though I was killing myself not being able to get my GSP file put together. And there's my little friend again. It's my best buddy. When I'm doing the moon shots, he's always out there with me. And a lot of the moon shots, I put him in. But it's good to have a friend, someone that wants to be with you, even if you are doing astronomy. He'll sit out there and wait for me and just sit there, and I can't believe it. He's a dedicated friend. That's pretty much my presentation.
All right,
for this
John,
time.
Thank you. Thank you so much.
Thank you. It's
Thank you.
my pleasure. I really enjoy doing this stuff.
Yeah, thank you so much. All
Adrian,
right.
thanks.
All right, so we are going to call this a night here. We want to thank all of our presenters that were on tonight. It was great to see Jerry Hubble after a hiatus here, and seeing them active with that big refractor, so I'm hoping to see more from them. And of course, we'll be back next Tuesday with Global Star Party hoping to have a couple of surprises in store. So you guys keep looking up, and we will definitely be back with more of our Global Star Party activities.
Yep, and John, we shut down another one.
Yes,
High
sir.
five, buddy.
Man, those are beautiful shots. I love that. One of the first ones you showed with the colors in the moon. That was spectacular.
Yeah, there's an APOD. Somebody really jumped on that.
I'll check it. Have a good evening.
You too. See ya.
Bye now.
Targus is on a mission to create smart, sustainable accessories to empower you to do more by using less. Sustainability shouldn't be a barrier to tech. It should be seamlessly integrated with how we work, play, and live. That's why we're on a journey to create a suite of tech accessories where smart design and sustainability are inextricably linked. We're doing more, designing smarter, dreaming bigger, and using less. Introducing the EcoSmart range of bags and accessories, a collection of products that not only puts the planet and people first by using a host of eco-friendly innovations and materials, but enables you to do more with your device while protecting and empowering your future. It's our planet, your future. Together with Targus, you've got this.
Come one, come all to the Southern Cross Astronomical Society's 2024 Winter Star Party, celebrating 40 years of stargazing, happening from February 5 through the 11th, 2024 on Scout Key in the beautiful Florida Keys. Get away from the cold and adjust your latitude underneath the pristine skies of southern Florida with breathtaking views of Eta Carina, the Jewel Box, the Southern Cross, Centaurus A, and of course, the magnificent Omega Centauri. Tickets will go on sale on or about October 1, 2023 at scaz.org. See you there.
Are your eclipse glasses safe for looking at the sun? Let's check to see if your eclipse glasses can handle the heat or if they need to stay inside. First off, never check your eclipse glasses with the sun. That's a good way to injure your eyes. Take your eclipse glasses and find a bright light, like a lamp or a flashlight. Hold your eclipse glasses up to the light and look through them. The light will appear extremely dim or not appear at all when looking through the glasses. For example, you should only be able to see the filament of a light bulb, but not the glow surrounding the bulb. Also, if your eclipse glasses have any marks or scratches on them, don't use them. If you have older eclipse glasses from a previous eclipse, give them a check to make sure they haven't been damaged or scratched. All safe eclipse glasses will meet the ISO 12312-2 standard. It's best to store eclipse glasses in a safe place where they won't become scratched or punctured. Remember, never look at the sun without eclipse glasses or a solar filter. Be safe and happy sun viewing, everyone. you.